I think I got the setup going on here. I have to adjust the settings of my monitor or you guys would not be able to see it. Not that you can barely even really see it, but earlier it was really bad. So if I put this up to brightness, you won't even see it. Like you're going through a lighted tunnel or something. But I just thought I would kind of start that out tonight before everybody gets joined to kind of keep it a little bit entertaining. And I mentioned this earlier, but I rearranged my room a little bit more to find stuff a little bit more easier to get around the stuff. This is supposed to be, this is C64 Studio. I mean, no, C64 Studio, C64. What was this called again, actually? Said player, C64 player or something like that. My disc just got stuck in there. It's actually Studio 64. There you go. So it's supposed to play music and everything, but for some reason it does not want to work. How fast do you want it played? Say 5 this time. 2? You can barely see the picture there. Be on. What's that basic program? Voice 1, voice 2. I have no idea what that says. Choose a voice. Okay, so choose a voice. You gotta pick one. Treble, clef. Choose a treble or clef. I'm just gonna play something finally. I haven't heard anything yet. I wonder if you need a special cartridge to play this, because I remember many years ago I had a cartridge, and I'm pretty sure that that's what this thing's looking for. Of course, I don't know the cartridge anymore, so I cannot play it. But I think we're kind of stuck not hearing the music on that one. Oh well, I do have other things I can show you. Maybe this is a demo. Okay, we'll just skip this one for now. These discs have been getting stuck in here a lot lately. I don't know why, this one really got stuck. Oh, great. This drive is like sucking on my discs right in. I don't want to give them back. So let's just kind of restart this. And run this one. This is a Lodestar. I showed this before I left last time in the last video. Let's see what it says. Please wait, booting Lodestar. I have no idea how many people is going to show up tonight. I was off YouTube for about a week. Figured it was time, for a break and everything, so I figured I'd, exit from YouTube. It's going very slow. Like misbehaving tonight. Usually there's a picture when Lodestar loads something. I think because this is the older Lodestars, they didn't have the pictures, maybe? I hear booting. Okay, it's doing something. I know you guys are going to see those menus. I can barely see them over here. I'm going to adjust everything. If I do that, it's impossible for you guys to see it. Of course, that's the only way I can see it. But give me a second while I go through this. Music isn't bad. Supposed to be a game in the summer. Picture of this. Fun and games. There we go. Maybe this is the one. Nope, that wasn't it. one. Come on, give me a break with this stuff. Probably nobody knows I'm here. It says I'm broadcasting on live on YouTube. Okay, time to put it down so you guys can see this. It's kind of what the screen looks like. It's called Fantasy Zone. Oh, it's a slideshow. Oh, it's pictures. And this is what I wanted. Oh, well, this is loading. I'm going to see if I can find something different on this one. Then I'll load pictures. Super bike. Sometimes interesting. I'm going to pull out a few of them here that I've had marked before while this thing is loading. It's supposed to be a picture of a, if you can see that, it's like an outer space thing. Actually, it looks a bit better if I do it like that. Not bad, actually. I can see it, and you guys can see it apparently. I'm in a spaceship. Alright, so Night Before Christmas, this is an interesting one. There's some really cool ones I'm pulling out here, I'm remembering now. This is a really cool one here. Okay, let's see what we got on this one. That's kind of cool, if you guys can see that. Kind of like a water scene there. So they better you can see it there, see the mountains there. And it's kind of like an alien planet or something. It's kind of cool. I should probably hook up my bigger TV. It takes so long to hook it up. But it wasn't, the idea wasn't to sit there and play with the computer tonight. I wanted to get some of the C64 Studio going. I'm sorry, it's the CBM Prg Studio. But I announced this kind of late, so people probably are not going to find me tonight. I sent out a request already. Okay. It's kind of cool. It's like a Halloween kind of thing. Like a woman in the middle, she's some kind of like vampire or something. And then there's aliens on the side here. This is an alien and this is the woman in the middle. I don't know who this is. Another weird alien or something. Oh, it's a rock band, that's what it is. Like an outer space band. You guys can see that. Some kind of like, it's called alien native. Some kind of a native alien on the planet. Actually pretty good over here. I just thought of something I could do. Zoom in and show it to you. I spill everything all over my desk again. You can kind of see it there now. That's what it looks like. Kind of cool. Whoops. Ringed planet. Still loading. Well, I got some discs here. I'll show this to you. Let me check this one out. Camera. You kind of see that there. Kind of cool, actually. Oops, I hit the key. Space Spelunker, it's called. This was actually pretty cool. Some kind of alien. Before it goes away, I'm going to show it to you again. It looks like a space alien or something. You might see in Star Wars or something. Whoops. Put the vertical one. Space Envoy. Still loading. While this is taking off, I'm going to figure out how to get people in here. I already invited people. Nobody's showing up. I got this set up so I can see it live on YouTube. It's kind of cool. It's like an alien head. And see, this one up pretty close. It's pretty cool. Once again, I have to adjust the thing. There he is. A better angle of him right there. Check it out. Pretty cool, actually. Okay. So I got one viewer, so I guess somebody is seeing me. That must mean I'm on YouTube. I don't see anybody in the chat yet. So I'm showing you guys some of the stuff on my Commodore computer. Oh, that one's really cool. I like that one. I'll zoom in again and show you a viewer. This is pretty cool. It's going to take me a moment to get the adjusting. By the time I get the adjusting, it already goes away. Let's see. It's too bright. one just doesn't want to come in. It's supposed to be like a space alien. Thought it was kind of cool. So we got 2 viewers. This is cool. So I need to. What's this coming up for? Kind of like an alien planet. I knew I should have got the bigger monitor. You can kind of see this one's like an alien planet. It's actually a guy. This looks like a guy with a gun when I look at it there. Okay, in the meantime, I'm going to try to figure out if anybody's in here. Just let this slideshow continue for now. So if you guys can kind of sit tight. I started it late tonight, so people are not here yet. What you saw in the chat is correct. We're going to be trying to start. I want to start building. Eventually, my goal is to start building games as often as we can. I was hoping to eventually get a community big enough where we could build a game every week. I thought that would be kind of cool to do. Trying to multitask here at the same time. So for those who are watching, what do you guys think about that? Go ahead and type it in the comments as soon as I can figure out how to get that pulled back up here. This one's kind of cool. It's like this outer space planet. I'll zoom in and show it to you guys. This one is really neat. I like this one. This camera goes out of whack. Check this one out. It looks like a giant planet or something. It's a pretty good artist. This was actually what was called the Lodestar artist. His name was Walt Harned. He did some really cool. He did all these slideshows, and he also did all the graphic arts for all this stuff. My camera is not obeying me tonight. I have one of these HD cameras, and it's like keeps going out of focus because the center keeps going out. This one's called Shuttle, the Next Generation. I think this is the space shuttle on this one. Pretty sure. So when Bo joins us tonight, we'll get started because eventually we'll have somebody here with a microphone. Right now, I'm just kind of killing time. This one's kind of funny. The spaceship, I don't know if you can see that or not. The spaceship sitting above a planet, and there's a satellite in the background here. That's what's at the top. It's a satellite. Show it to you again. Kind of see what it looks like there. Come on. See it? It's kind of cool, I think. I'm just goofing around a little bit tonight. Like my camera. Okay, so I need to start figuring out where everybody is, whether they can't find me or what's going on. I'm going to take this link and put it over there again. Go into my channel, the videos, and we'll take a look at this one while I'm waiting. This one's kind of cool. This is like Close Encounters of the Third Kind. I'll show you this one. This one I always like this one. Check this one out. I'm just gonna have to adjust it again, but you can kind of see it. It's like a spaceship there. Camera doesn't do anybody justice, but it's actually a spaceship. And it's sitting on like a planet there. This camera doesn't do any justice because these pictures are really, really cool in this, you know, on the Commodore 64. I'm almost ready to hook up my other camera. Okay, so let me, got distracted a little bit, let me go back to my YouTube channel and see if this thing is broadcasting yet, which it's not. This one says orbit. I think I showed this one earlier, but it's really cool. It's like the first picture I showed you guys. Okay. So bear with me a second while I figure out where everybody is and how to get people in here. Last week was such a success, I thought. We actually ended up with 143 views for the whole week for that video. Even though it was like 7 hours long. Yeah, I've been trying to figure out how to set up this stream also on YouTube. I'll show you that here in a minute. I guess we're probably done with that. I'm going to switch over probably to the desktop for now, so you can see what's going on over here. Of course, you're going to get like a billion screens when I do this. So you can see my YouTube there. So what I'm trying to do is set up a stream here for this. I've never used this before. But it's really cool. It's got like a chat here. I think it just says you have to download the software. I saw that earlier here, but it wanted me to create an account, which I guess I could do. Windows. Okay, so it's going to download Wirecast Play. ScreenFlow, Wirecast Go. Let me see what this is. Oh, it's downloading right here at the bottom. Oh, this is a pretty big file. 149 megabyte. While that's downloading, I'm just going to take a look at this for a second. You've got to set up the stream software. And this is just for games or what? It says offline up here. When I click on this, I noticed it didn't do anything earlier. I think it's because I don't have the software installed. And here's my video. Okay, we're getting somewhere now. Stream's current bit rate is lower than the recommended bit rate. We recommend you use a stream bit rate of 2500 bps. Okay, how do I change that? Like my video streaming down here or something. So 2500 kbps. View on watch page. Go live now. I wonder if I can change it when I click on this. See what happens. Stream is offline. It's got to be something to do with the software. Okay, so it downloaded. 64-bit, 32-bit. I'm going to do 32-bit. I don't know if I can trust what 64-bit's going to do. It'll be just a moment, guys. While I work through some technical issues here. Lost my screen again. Okay, so it wants me to install this. Installer is ready to be installed Wirecast on your computer. Virtual microphone, I don't know if that's going to be good or not. Put it on there. I see so many people do streaming. Okay, so it's installed. Okay, no excuses now. Everything's installed now. You should let me on now. To live stream, start your encoder. Learn more. You need to download encoding software. I did. I got this one. Which was one I just downloaded. It says beta version. How do I start streaming? Why do they make this so complicated? Open your encoder and start streaming from there. There is no start button in the live dashboard. I don't see myself streaming. Or it would show something here. Maybe I didn't click on it. Let me just click on it again and see if it shows anything. It might be working. Here, maybe I can click on it. Let me just click on it again and see if it's working. It might be working. Here, maybe I can click on it. Let me just click on it again. I'm going to mute this so we don't get a double echo. But got the streaming going. Fortunately, since I should lower it to 2500 VPS, people are probably going to complain about that. I don't know how to do that yet. It's not very friendly, doesn't appear to be. Live control room, you can't click on this. Analytics. So I can see two people viewing. Got some interesting analytics to it. So again, guys, for those who just joined, we're still waiting for more people to join. Did this just open up another window? Or did I just lose my screen? Still got this running in the background. I wanted to show you guys this game. They said, well, we're still waiting for people to join. This game is really cool. If you ever remember the game Gauntlet, this game, back in the days, I used to play this so much. I need side 4. Side 4. So we're going to lose the pictures for now. We'll fix this again. It's like when I drop it like really, you can almost see it when I drop the brightness down. Okay. I think it's low dash to come in 1. Let me see if that's it. That might be what it is. Okay, list. Oh, this is the Lord Star stuff. This is it. Yeah, this is it. It's called, I can't use, it's called More Tracks. I had to brighten it or I cannot see it. It's a really cool game. Meantime, we'll wait for more people to join. I'll check the chat. Nobody's in the chat yet. Probably because people don't know where I am. Let me copy this to the... wait. Your screen sharing present to everyone. Did I not do that? I thought I presented to everyone, but I guess I didn't. That was my fault. Okay, this is going to take a while to load. It's a pretty long, it's a pretty big file to load and everything. I certainly hope we get some people to join here. Let's see if I can go and paste like any of the links in here somewhere. Open chat in the new window. Like chat in the new window. Oh, there we go. There he is. Well, I see you, but I don't know how to get you on the screen. Okay, so let me go to his message here. Somebody, Darren is somebody that was here last week, and why is he not showing up here? Sent me a message, it should be right here. This thing's gonna be a while to load. Yeah, it's not showing up here either. Okay, view on watch page. Let me go there. Maybe that's where I have to go. Ah, I think I finally found it. Okay, I found it. It's gonna be so loud. Why can I not? Trying to multitask again, guys. Trying to figure out what's going on over here. Why this is not loading. It's still not loading. Why not? I'll do what it's doing now. We'll just have to wait to see if it comes back. Alright, so let me just take a look here. I see the stream here, but I can't add comments to it, so I'm trying to figure out how to add comments here. It won't let me add comments to it for some reason. Maybe if I refresh it. This is really weird. Why can't I comment on my own thing? See, I see Darren's message and I don't know how to respond to him. This is really weird. Pop-out chat. Let me see, pop-out chat. Oh, okay, I got a pop-out chat. Let me just throw the link here. Okay, so I think we lost the game. The bummer, it's a really fun game. I'm wondering if we have to load it directly inside of Lodestar. I know it works. I'm gonna make my second attempt here, get this thing going. I sent a link to Darren, who was here last time. See if anybody joins me. Let's see here, we popped out. Okay, this is going to add people down here. No. Add remove moderators, view active users. Oh yeah, it's going to take a moment to load this one. Okay, here's where we got last time with it. Fingers crossed, see if it works this time. I think I should use the fast loader. Alright, the drive light's still on, that's a good sign. Last time it kicked off. While this is loading, I'm going to keep looking to see if anybody's here yet. I just not realized I could go in this other chat and I could put the link there too. I think I'm going to do that. If they're watching the other video, they'll probably see this one. Let me do that. Okay, so I just put the link in the description for the chat. Let's try this again. It says F1 to play the game. That's what I did last time. Light's not on or anything. Okay, I'm pretty much done with this one. It starts loading. Alright, what side does it want? Side 4. Uh-oh. This one's really cool. It's called The Night Before Christmas. All through the house. Not a creature was stirred, not even a mouse. Yeah, this one's kind of cool. It's got some sprites in it. You can barely see the text. If that does anything good. Kind of like I cannot see it. I'm going to move the camera to show you. This is kind of cool. See that or not? It's a duck moving across the screen to the tale of The Night Before Christmas. I'm very talented at holding my camera. Sugar plums in your head. Yeah, I know it's not Christmas, but it's kind of cool. That's kind of long. You can see the little city there. Can't do this backwards for anything. I'm going to write out of that, change it. You see that little snow falling? I'm just gonna leave it like that. See the Santa Claus in the sky? Little sprites moving around. I'm so tired. Flying saucer. There's the reindeer. The slow reindeer. Pulling the sleigh. There's actually some messages down here, but you can't see them. Go back to the living room. It's gonna get interesting, I promise. There comes Santa Claus. Not a bad looking sprite. You can actually see him. A little better. Oh, that was a pretty good sprite. And just twisted. Come on, give me back here. You can see a little bit back of the sprite there. It's actually pretty good. He's hanging the stockings. Some great sim music, I think. And he got beamed up. Is it beamed? Yeah, instead of Santa going up the chimney, he got beamed up to like an alien or something. So many great themes for Christmas, though, huh? There's some really great programs on the Lodestar. No joke. And the tree's kind of blowing. Merry Christmas to all a good night, of course. Yeah, so that's about it for that. Thought you guys might enjoy that. But not again. I'll probably have to change the name of this hangout tonight because it's not exactly what we're doing, but I couldn't get nobody to join because it was my lapse of short timing to get people to join because I didn't know I was going to do it tonight. Let's put something together. We'll probably go over the other stuff later or next week. I'll be right back. If you like polka music, I don't much like it. This is inside 2. Put that under. Where is this one at? Here it is. Secret identity. I just now thought of something. I can mount my camera on this, and it might stay. I use it to when I do my editor videos. I might just be able to stick it on the top here and mount it. It's actually not bad. Cool, this actually works out pretty good. It's gonna be a little bit crooked though. Turn it around. Not bad actually. I get it closer. Not bad, eh? What do you guys think? Think that's got potential? Maybe move it up a little bit, hopefully it doesn't fall off. I got it on my tripod now, so now you can see it a little bit better since we're going to be focusing more on the monitor stuff tonight. This one's called Secret Identity. Let me see if I can just get all this back up the way it was. Hey! I hear somebody coughing. Okay. Oh, cool. I got actually a couple people here. This is awesome. So anyways, I was going to show you this. I mounted my camera for now just to show you this. I wanted to show you this because this guy, his name was Tony Rose. He created this stuff for the Lodestar. He's probably one of the best graphic artists I've ever seen from using character sets and stuff like that. It's actually done with a character set. I don't know how much of this you can really see. I can't move my camera up much closer without bumping in the thing there. But I guess that's not bad, right? So anyways, press indicated, continue. and you could play this. It's some kind of a game that he created, and it's got like questions. This guy was like a comic book fan. I know you're not gonna be able to see these. These are questions. And so, what is the secret identity of Captain Marvel? I don't know if anybody knows that. I don't know. He was a fanatic over this stuff. I never won the game because I'm not a crazy comic book fan, so I just clicked one of these, and of course, Billy Madsen. The secret identity of Darkhawk? I have no idea who that is either. Once again, wrong. Secret identity of Spider-Man 2099. I don't know, these are some weird names. They're in blood. Oh, I actually got one right finally. The Silver Surfer. I think I know this one. No, it's not Luke Cage. I think it's Norrin Rad. Yep.
Steve, you're back. Can you hear me?
Yeah.
Hey, I'm still getting stuff together here.
Yeah, that's cool.
I just got in, and you were away, but I'm still. I just got home.
Oh, that's cool.
Give me a couple minutes.
Can you see that screen much?
Yeah.
I put it on my tripod.
Yeah, I see. Dead center is a monitor.
Okay.
I'll be right back.
That's cool. I'm going to throw up a different game. So those who are still watching, this is another one by Tony Rose. It's called Inertia. I'm going to throw this one in. I have to work around the tripod here a little bit. That tripod idea was a good idea. Okay, I saw John Pearson. Are you still in the chat, John? But he left your chat.
Yeah, I'm back.
Okay, cool.
I ordered pizza, so I'll just step away when the pizza guy gets here.
That sounds good. I'm trying to cut back on all that stuff, though. I've been like eating like crazy all week.
Yeah, I don't have any food in the house, and I was in St. Louis all this morning. Early evening.
Right here. So I was showing everybody the other one I had up earlier. This one's called Inertia. There goes the screen again. This is the same guy that created the one earlier. He's like one of the best Commodore 64, how do you say, graphic artists I've ever seen that does like all the games and stuff like that. You'll see what I mean when I get this one loaded. So it's got like game characters in that he created. You see that? Look at those graphics. Not bad for Commodore 64. The camera's not doing any justice at all. Alright, that's getting a little annoying.
Was that the fantastic? No.
I have no idea. It was just some graphic characters that he created. You could see him there a little bit.
Kind of look like X-Men, the Hulk or someone.
You're supposed to avoid this stuff. This is your man at the bottom flashing there. Right there, he's moving. He'll run into this stuff. This was written in BASIC too, and you can't. You're supposed to pick up these things, I think, right there. I'm gonna crash him. This guy keeps saying, "Soon you will be mine," like the Grim Reaper.
You ever tried a capture card? Better for showing stuff like this.
Oh, capture card?
Yeah.
How do I do that?
Well, you output your Commodore 64 into the capture card. Like I've got one that's a USB. So it goes
That's
USB to my computer, and then it's got composite in. It actually has composites and S video, I think.
Oh no, I haven't.
And then it's like there's capture software to view what is being put into the input of the capture card.
But would it still depend on the video card you have? I mean, so not video card, but the video camera you're using?
No, so no camera. It's the capture card. You're plugging the C64 directly into the capture card. That is acting as your monitor, and then you plug that into USB in your computer, and then you've got software to be able to view what is put it into the capture card.
That's the first time I've heard of that. I've heard the word capture card, but I didn't know that Commodore 64 had one.
Well, it's not anything to do with Commodore 64. It's just actually this one that I have is for recording cable TV. So I also have my cable box hooked up into it, and then I can set on my computer. I can record shows on my on the TV through this card. Well, rather than hooking up to the cable TV, I can hook it up to a Commodore 64, and record that as well, right?
Yeah, actually, I know what you're talking about now.
Yeah, so it's not a card. It's actually a little box, USB box. Howpodge is the one that I have here. I've actually not used it on the Commodore 64. I've used it, like I said, to record television.
I had mine around here somewhere now. Where would I put it? I got it so unorganized last week. Mine is like it plugs into the back of a cable outlet. Trying to go to another screen and it won't let me.
The one I have was like $80, but I've seen recently that they have cheaper ones that are smaller and just have one input. This one's got several inputs. I think it's all like $20.
Let's see what I do with mine. Usually very good at knowing where everything is. There goes the camera. Oh, I got it sitting on top of my tripod. Got both. Now it doesn't want to stay. There's something wrong with my camera too. It's like the center of it. Whoops. The center is going out. There it goes. I have to snap it back in every time.
Yeah, it was real crazy there for a second.
It's still a little blurry. Ooh, that actually getting better. Yeah, I was trying to look for the thing and I bumped it when I got up. So what else is on this? There's a jukebox called Shockley Jukebox. Side 3. Anytime I'm going to look for that piece again. Probably going to get a shot here somewhere. Have you been working any more on that demo?
Yes, I have it. I have it on the screen share.
Really? Awesome. I'm going to show you on the camera what the one I have is. It's probably not the same thing, but this is called a Pinnacle HD TV. Have you ever seen one of those?
Oh, okay. So it's got like a coax in, huh?
Like a little thing, yeah, on the end. You can plug it into. I don't have a coaxial on the monitor, so I can't plug it into this, but I usually plug it into my large TV.
Yeah, if you look at my screen right now, I got up on Amazon the one that I bought.
Okay, let me switch over here for a second.
It says it's $96 now.
That's kind of cool. Look at that. It's like a Wheel Fortune thing or something. Let me see.
Oh, there's my pizza.
Okay. I'm going to see if I can grab my TV. Are you doing that? Technical difficulties, guys. While I try to hook up the TV. Hopefully. Let's see, what else do I need on this? We're going to probably have to switch to the screen here for a minute. Unless you guys want to watch me hook this thing up. Gotta set it up in the background here first. So this one is like this game anyway, for those who are watching. It's like a trivia kind of game. You just press the numbers, I think it is. Or even a joystick. I have no idea. It says press H for help. Cursor up, down, that's the cursor keys. That's what it was. And it plays music. So I'm going to move it up here. And start with the first one, and we'll just go through them all. Ragtag jukebox. I think enter will do it. Fire button or something? Right, so I'm on it and I pressed enter. S for sound. Didn't have the sound on. Cursor keys to scroll, text, other key to leave the help area. You have to hit the space bar. Space bar. That's what it was. I think. try to figure this out real quick here. We'll get back to the TV. I'm hitting enter, press inspire. Nothing seems to want to load. There's like a star next to it, so I know it's selected. How you can play it, I don't know. Let me see. Press some keys. Ah! I think I discovered the key. It's loading it now. To my TV. There's the jukebox going. Wait, where's the remote? Okay, let's try a different tune. That one's getting boring. It's called the Shockley Rag. Let me get out of this. Key again. Okay, so you hit a key again. I think I get it now. Don't they sound all the same to you? I think they all sound the same.
Yeah, this all sounds like Calliope music. It's not very, I mean, it's only using one voice. It's not, I mean, even for the C64, it's not doing a lot, you know?
Probably so. I'm still investigating where
Within one place.
I just found my cable. Yeah, this can get boring really quick, huh? Weird voices.
Well, there are some subroutines I really like.
Really?
Sure.
Okay, I'm trying to figure out how to move it again. It's still loading again. There's a different one. Oh, great, I need another cable. Oh, man. cable to plug into the TV, plug into the switch box, and plug into the commodore, and plug into the Pinnacle. Right. Oh, it quits after a while. I need one more. I might know where it is. Found it. Did it switch to another song? I didn't pay attention. Okay, this is the longest one. I'm going to make this one the Commodore. The short one the Commodore, the long one this. Switch that over for a second while I look for this other one. Where did you go? Oh man, I hope it's on here. I reinstalled Windows, it might not be on here. Here it Did you change the sprite on that ball? Still eating.
I did. Sorry, I'm still eating.
Yeah, okay. Sorry, I gotta plug this thing in anyway. So I gotta do some work around here again.
I'm having trouble hearing you with the music going. Sorry.
Okay, I'll turn it off. No, I said you changed the sprite on the Commodore ball. I saw that.
Yes, I looked into how to do multicolor sprites.
That's pretty cool. I like that.
I don't see your screen anymore or your camera.
Yeah, I turned it off, so I was trying to get the bigger TV up. I'm hooking up the TV Center Pro like you said.
Well, so that with
Are you seeing anything?
coax, you're going to need an RF modulator, otherwise you'll probably only get video. So
Yeah, that's it.
I would put the Commodore into like a VCR or something that has, you know, something that will give you a modulated signal out, or an RF modulator if you got one.
I'll show you what I did here.
You're not going to get an RF modulator that has coaxial out usually, so that's why I say a VCR, because, like, you know, VCRs have coax in and out usually.
Yep, I know what you're talking about. I'll show you. I'll switch it back over. What happened to my thing?
I'd step away again for a second. Be right back.
Oh, I didn't mean to do that. There it goes. Now I have to move it out of the way. Do you see it in the background there? Take the monitor off. Whoops. This.
I'm back. I see your camera again.
Yeah. It was on and it just went off. I just thought it went off. Again, click. Trying to figure out what happened. Oh, when I unplugged this. What the world? How is this going to here? When I had this plugged in, it's going to shut up. I probably pulled it back out of the computer, didn't even know I did that. It's working perfect a second ago. Oh, TV signal's out. Try it again. Oh, I changed the channel, that's what I did. I was like, what did I do wrong? Come back on. There it goes. Now I just have to change the brightness on it and everything. So I have it running into the Commodore. I'm going to plug it into the Commodore. Off the table if I move it anymore. And I just go and I change the brightness settings on this. Actually, I can probably move it up here. Much better. It's kind of lopsided though. I think I need to put a book under it. It's lopsided. It's not bad, I think. seems like it's a little crooked. So it's running on my LCD now. Trying to look at it from the camera perspective. Is that straight? No. There's kind of centered now. And then when I adjust the brightness settings, it'll look much better even. Now the next trick is to figure out how to get it running off the computer. I just have a menu. Yes, I get full brightness. I drop it down. It's coming really good when I drop it down. It's still crooked though. I need to pick the book. Should do it. Let's see if I'm going to get it. Straighten it out a little bit. So I got the camera sitting on the tripod and the TV hooked up to the Commodore with the RF modulator, like you said, because there's a built-in RF modulator port on it. And we should be able to switch it over to the TV center. So we should be able to get the computer screen up here once I can get this working. Figure out how to do this. Okay, probably have to load the channels again or something.
You have a splitter or something? How are you getting it to the TV and to your capture device?
How am I getting in? Yeah, I have a splitter. I have a splitter run into the TV, run into the Commodore, and then run into the TV center, which is not working.
TV center, that's your that's that Pinnacle capture device?
Yeah.
Okay. I think mine was called a Win TV.
Win TV.
Yeah.
But you can get this one free online. It's called TV Center Pro.
Huh.
So I figure out how to switch this over. It keeps saying the PC device is not connected to the computer. I guess I can plug it in again. I'm running out of room to walk.
Does it show up in your device manager?
I'm just going to plug it back in. It's one of those plug and plays. Again. I didn't hear a sound when I plugged it in. Whoops. Dang, I unplugged it again. Turned off the whole thing. I was walking around and I stepped on the power strip. Oh, we just lost everything.
Yeah, the video might be frozen. It's just kind of showing the TV. Although,
it's still plugged into the Commodore, so it should come back on.
Yeah, there you go.
Load. At least the channel too. Probably the Commodore gave out. Yeah. My Commodore has a bad chip in it, so after a while it just shuts down. Now we really need to get that camera going again. I'm going to switch back to the screen so I don't keep people bored here. Switch back to your view. And, well, I guess I could switch back to mine to show you what I'm doing over here. So this is the TV center right here.
Oh, I'm just seeing my screen right now.
Oh, you're still seeing yours?
Oh, there you go. I see it now.
This is the TV center.
Mm-hmm.
It's still saying device is not found. Possible reason your PC device is not connected to your computer.
Go to your device manager. You see I got my device manager open here? Mine showed up in sound, video, and game controllers.
The TV center's in there. Oh, device manager. Okay. Hold on. Control panel. It's really weird. It's like I always have to install the channels first before it lets me do anything with this thing. I don't quite get why it does all this. If I just scan over Chan right now, I have to start to scan. I don't know if you can see that. I'm starting to scan.
Oh, I thought it said it couldn't find your device.
No,
Yeah,
no,
it
won't even load. It doesn't
oh, you're
find
not
the device.
connected yet.
Yeah, but it won't even load TV Center if they can't find your device.
Sure. Yeah. Did you find it in your device manager?
I had that up here. Can you see my device manager now?
I see something with an exclamation point next to it. Serial ATA controller, though. That's like a disk controller, right? That wouldn't be it.
I don't think that's it. Where else would it be here, right?
Open up where it says sound, video, and game controllers.
That's just my camera. And that Wirecast streaming I installed earlier. Fresh when it.
Yeah, it's like you're missing a driver or something. Did that TV Center come with any drivers?
Yeah. Yeah, unfortunately it doesn't. You have to kind of go over here. Oops. I know what it is. My channels aren't hooked up because I haven't scanned my TV yet. You have to scan the television channels first. I played with this thing enough to understand it. And because I just hooked up the TV, I wasn't hooked up to a DTV. And then now I have to scan the channels, which means I need to plug in my DTV also. Let me switch back over to the camera view so I can see what's going on. Wish there was like one button you could switch everything back and forth. That'd be kind of cool. How do I get back to my camera? Camera disappearing now. Probably got to. Let's see. Like when I loaded that, it knocked out the camera or something. Probably because it can't do more than one screen at a time. That's probably why. Can you see it now? My screen?
I see the camera and the blank TV screen.
Okay. So I need to get the TV plugged back in. I threw everything in the closet, so I was fortunate to know where everything was.
Or for me to see it on Hangouts, you would have to switch your video source to the capture device. Like my capture device shows up in the list of. I don't have a camera, so the only thing that shows up in there is my capture device.
Oh.
You know, if you go to settings, video camera.
Okay, I'll show you what I'm doing now. So my GTV is hooked up now. I just have to scan the channels here. Remote's acting really weird. And then you scan them here. I got a really old TV. Can you see that scanning channels?
Yeah, kind of. It's pretty washed out. It's like really bright.
Oh, let me go. It's this display settings again. And it won't let me do the menu when it's doing that. So anyways, it's scanning channels. If you see that number in the middle there, right here, that's scanning the numbers of how many channels it's finding. So it says analog 30 minutes for completion, NTSC channel 45. Eventually where above where I showed you the number above it, it says not found right now. It'll start changing to found every time it finds a channel. And then you'll see the channels pop in, of course. And we'll be able to switch the TV center over and get this thing going, hopefully. I can get this going every week. It's a hassle though because I gotta move the TV in here. I gotta hook it all up. You know what I mean? I wish there was an easier way, like to make a Wi-Fi in my TV over there or something.
Yeah, I think you really want to. If you want to show your Commodore 64 capture card, I think it's much better.
Say that again.
Of course, you could be doing all this in emulation right on your computer, right? But if you want to use your actual Commodore 64 to run this stuff, I think a capture card would be the way to go, or a capture device like you.
Oh yeah. No, you're right. I want to be able to emulate what's on my desktop on the bigger screen. If I wanted to switch out to the Commodore computer, I could easily do that too. It's going to take it a moment. It hasn't even found a single channel yet. This progress 51%. You got to put something in wrong. It's got settings on the TV, but I don't know how to adjust them either. So like all the way over on the side. Maybe I can do it right here while I'm doing that. Oh, many of them won't work when it's on. All right. I guess it won't let me do anything. It's because this is the menu. I could always do this if you want to see it. I can't hold my hand straight. You see it now? I cannot hold my hand straight for anything. See what it says now?
Yeah, it was. I mean, it was all right before. I don't.
Okay. I didn't know if you could read it. I still have the tripod. I just put it right back on the tripod each time.
I can kind of read it. I don't know. Does it matter?
I know you were asking me earlier if you couldn't read it, and I was like, trying to fix that for you. Oops.
Well, hopefully you won't have to be pointing a video camera at a TV screen after you get this working, right?
Yeah. Well, this is just to keep everybody entertained for now. But I didn't, not like I planned all this tonight. It was like hoping for Bo to show up, but it was my fault. I didn't know. I took a break from YouTube for about a week. So I wasn't even planning to do one tonight. And I saw you and a few other people. I was like, okay, I better do something.
Yeah, I've got some questions for you if you. Like,
yeah, it's going to take a while anyway. If it works.
If you want to look at my, I'm sharing my screen. You want to look at my screen?
Yeah, I can put yours back up. It keeps popping in when you're talking. I can't really see your code very well. Maybe enlarge it a little bit.
I'm sorry, say that again.
Enlarge your code a little bit. It's kind of hard to see it for the viewers too. I like how your ball changed color. That's nice.
I couldn't hear what you said. Your HUD?
Oh, I said, can you zoom in on the CBM?
Oh, okay. Here.
You know, then people can now see it a little bit better.
Yeah, so right off the bat here, one of the things that I did is I went up here to the tools, and I did a generate syscall, and it put this bit in. And you can see what that does is now whenever it launches, it'll automatically run the program.
Oh, that's cool.
Right?
Like kind of like a model loader or something.
Yeah, this is just. I think this is exactly what gets generated from this string of bytes, and I think that 801 is where BASIC starts.
That makes sense. What do you mean with CBM starts? Because it's not running BASIC, it's running the same language.
This is BASIC. 10 sys 49152, and I believe that this is the address of where BASIC starts on the C64.
Well, what I mean is the top line's commented out, so that's not doing anything, just showing you what's there. But the bytes is what's, I think it's setting a starting address to the start of C64. I'm not by C64. I've seen both.
I can figure out how to hit run break here in Vice. I'll hit list and you'll see that. Okay, escape.
Yeah. I like how it changes colors. That's kind of
cool. You know what key to hit to break into the routine?
Into CBM?
In Vice.
Or in Vice? Let me just pull mine up real quick. I don't even have mine running, I don't think. We actually do.
I thought it was escape.
I think it's one of the F keys. Oh, mine froze. I can't do anything with mine. It's F. It's the only thing you can do is go to the edit, like to the menus at the top there. You can stop it that way too. But I don't know.
Well, I want to do a run stop. You know, I want to break the program.
Break back to the code?
Yeah.
I don't know the commands for it. Of course, I don't have mine running like yours, so I can't see. Try the F1 keys.
Yeah, I just tried all of them. None of them did anything.
Is there even one to break it? And if you hit monitor, it's going to reset the whole thing.
Yeah, reset the whole thing.
That's probably all you can do. Let me see if I get a soft if that does it. You know, soft just restarted the whole thing.
Right, but basically this byte string is this written here, starting at basic. So if I were to break it in list, this is what you would see: 10 sys 49.
Oh, good.
Right.
Oh, I see. So it kind of runs it like the old Commodore games did whenever you wanted to run a game or whatever.
Right. This byte string here is writing this basic code, line 10, sys 49, at this address, which is where basic starts. And it's just the syscall to start our program down here.
It's just like hard coding the program, sort of.
Yeah. So one of the questions I had for you is, where did you come up with this address to stash the sprite, and how are you telling the program that's where sprites begin?
I'm sorry, I stepped away trying to look at my TV. Just went blank again. What was that?
I said my first question is how did you pick this address to stash the sprite data, and how do you tell the rest of the program that is where the sprites are located?
Oh, that was the ink bin, and then you just put a label beside it. Where's your sprite data?
Right here.
That is your sprite data?
No.
So you said a label for it.
No, right here we've told it that this starts in this at this memory address, right? But this is not the default memory address for sprite data. The default memory address is 2000 something. Oops. Oh,
What was that?
what happened there?
You should put it on the taskbar. All right, we're back. Might want to enlarge the
This
code.
is the default address for sprite data, right?
Yeah. So that's where it's
Not this address. So I was like, where did you get this address from? And where in your program did you tell it that that's where the sprite data starts?
Where did it get the 16320 from? It's kind of hard to see your screen again. You have to enlarge your CBM. I know it's annoying. You have to do it every time. Okay, I can see it again. You just erased it. So you wanted to know where that is being stored?
No, where did you pick? What caused you to choose this address, this particular address, 16320? Why that address? Why not? All right, this is just gonna.
I know.
Every time I hit plus, every time I increase my font, but the default address for sprites to start is around 2000 in hex.
I was going to show you. I need to switch to my camera view again. That was one I chose earlier?
Yeah.
I think I just randomly picked it. I don't know why I picked that one.
And I can't see anywhere in the program where you're saying my sprites are located at this address. Whereas I made another program here that read the joystick and did two sprites at once. Here, I'll show you that.
I guess I'm asking, what is your goal? What are you trying to do next?
Well, I'm trying to understand how all this stuff works.
Okay.
I was looking at the program that we did last week, and like I said, I modified it to have multicolored sprites.
Can you pull that one back up again?
Which one?
The one that we did. So
this is the one we did, yeah.
And you have to enlarge the screen again.
All right. As soon as I do that, though, I won't be able to go back. That'll be the only one that I'll be able to go to. Let me try this. No.
Does it always shrink the screen every time you go back? CBM is just kind of weird.
Do you not see what's happening here? So if I show you ball.asm, which is the one we did, and I go increase the font, and I try to switch to my other program, which is called joy.asm, it crashes. You see the crash window now? And that only seems to happen whenever I increase the font size, right? That's why I wasn't increasing the font size there for it.
Maybe it's a bug or something.
Because this seems to be crashing every time that I do that.
Oh. I was saying it for the viewers.
Yeah.
Because they're going to be able to.
I understand, but
yeah, it's all good.
It's causing the issues. Can you see the Vice window here? Here's the program that I wrote that reads the joystick. I've got a joystick here that I'm moving around, and if I hit fire, it'll put another sprite there at the spot where I fired. But this one, I don't understand what you guys are doing with the most significant bit. What I would like to do is I would like to have the ability to address directly a 16-bit number. I'll basically use two of the 8-bit memory locations and put them to, how do I get How do I tell the assembler to use both of these addresses and not just the 8-bit? I want a 16-bit number. I guess where I'm at here, and I think that's where the most significant bit comes in, right?
Yeah, the 53,269, you have to set that to 1. That turns it into the high bit. But remember, once you do that, you're going to lose the resolution. As Bo explained last week.
Yeah, so I don't understand that either. I figured that out, that what he was doing is he's basically moving in the X direction 2 for every one that goes Y by sort of the method he's doing. He's doing like a bit shift left.
Yep. What did he say the size of the screen was again? Do you remember? Was it 310 or something?
I'm sorry, say it again.
Do you remember what he said the size of the screen was?
Yeah, so across it would be 320. And then horizontally is 320, vertically is 4 or 240.
Okay. Stop mining, go back into.
All right, but yeah, my first question here was, whenever I tried to write another program using this, it didn't work because it couldn't find the sprite data. So in my other one, I set the sprite data where the default is. This is the default address for sprites, and I didn't have to do anything to tell it that the sprite data had moved. Whereas in the one we did, you guys had this address that you picked at random, I guess, to put the sprites, but I couldn't figure out what command down here that was telling it to look for sprites there.
Oh, okay.
Going to enable the sprite was the same thing that I was doing. You were just setting this bit, to turn the sprite 0 on.
Let me go back to my. So. Let me just take a minute to look at this for a second.
Yeah, you want me to send this to you somehow? Paste bend it or email it or something?
Yeah, I'm just trying to look at the other one here, see if I can see what you guys. I have a different code from over here from last time.
Sure, yeah.
Okay, here it is, the ink ball. Oh, I see. So you're wondering, I'm looking right at my code now, I can see it a little bit better. So I started at 16.320 because that's supposed to be an open area for the Commodore 64. I don't know why it shows that one. I found it in the book somewhere, one of the Commodore 64 mapping books, and it's open memory. Anyway, safe to use on the Commodore without bumping into BASIC, because I used to write like BASIC and machine language together.
Right, understand it's just free memory.
And then that basically instantly will load it into memory based on, it'd be the top part here. Do you see where it says, let me see what your screen looks like in my screen. So go to the section where it says load number 1, right below where yours says write X.
Right there?
Yeah. And you see below that, your screen's going to be different than mine. I have to look see where yours is actually load number 5. So this, the sprite color, I didn't actually put all these in. So this is sprite color, the enable sprite. The one we're looking for is, let me convert it here. It's 2040. I don't have the hex memorized, so I need to look up, see what I put the hex for. Where's that hex? I think we did it down in that code somewhere. I'm trying to see where we pointed it to the sprite somewhere. Where is our code at? Let me see. We didn't create, in my example, we don't have a label for it or a symbol for it. I'm kind of flabbergasted how we did it here. Unless it just instantly figures that out. I think what's going on here, because you can change the shape by using memory address 2040 to point to where the next sprite is. And that will This is what Bo was trying to demonstrate last week. I wish he was here tonight, but let me just pull my screen back up here again. 2040. 2040. Oh, I just realized I gotta get mine running or it's not gonna show it. Oh, I forgot to load mine back up again. It went back up. So let me switch over to my screen again here. Oh, I still got the TV up. I need to switch to that. Oh, your screen. Can you see my CBM up?
Yes, I see it.
Okay, so I'm just going to run mine for a second here. I need to make it so I can break out of it. That's what I need to do, actually. Let me just have a break for it.
Oh, that's what I should have done to show you the basic system. I
just need to break out so we can see the sprite alone. So when I run it, show the sprite like that.
Mm-hmm.
And this memory address right here defines where the shape data is for the sprite. I have 255, I don't understand. It's probably because what sprite we use sprite 0, right? Yeah, we use sprite 0, right? Okay.
Are you there? Are you there?
Yeah, can you hear me?
I lost you there for a bit.
Oh, okay. So I don't know how much you heard from it. I was just saying memory location 2040. You probably don't have this book, so let me get the internet book up again here. Actually, it'd be easier if I just pull mine up. Oops, why did I click on that? Commerce 64. Did I not download it? See, I did a habit of not downloading it because I already owned the book. Now if I could download the PDF for it, it's not here. Let me just go open the internet window here real quick.
Yeah, I actually downloaded it. You gave me a link last time, Bomber Jack.
Oh, you did? Did you download? What I'm trying to do is get the map in the Commodore 64 on my screen. I just go like that, C64, and it'll pop right up at the top. And so this is the block right here that I'm always referring to constantly. Why is the PDF not showing? Maybe I click on this right now. So it's downloading down here. So I don't have to keep switching back to the camera. Make this easier for people. In the old days, I had a bad habit of just like showing everything directly in the camera. And people are like, you need to show the screen more. I'm like, okay.
Mm-hmm. Yeah.
I have to change that approach. Now I just download the PDF and open this. It's going to take a moment to load this thing. Get back over to folder 2. Since I'm neat and organized now. That's to be learned. Not organized person, become an organized person. That'll change your whole life. So this will take a moment to load. Oh, that was pretty fast. And let's get that here a little bit. I need to get past the 0 page. Zeros from 0 to 255. You get into where all the sprite data is. It's actually called screen memory right here. This is where you already probably know about the screen. This right here, can you see my screen?
Yes.
I need to enlarge it. This is where the sprite shape data pointers are located, where you can do all the animation and all that. I couldn't remember it. It's sprite 0 starts at address 704, 11 times 64. It continues for 63 more bytes up to 767. But what we have to do apparently in this program, we have it defaulting to this sprite data, which you probably didn't catch this. Do you have sprite pad on your computer?
I do now, yeah.
Okay. I'll show you what Bo did. It was already reloaded in the memories when he had it preloaded. Now I gotta see if I can remember where I put mine. It should be in here somewhere. Character pad, sprite pad. And I don't have the file he did, so I can't use the exact file. Oh wait, no, I actually do have the file. I'll try it. I already have it right here in front of me. Let me just quickly see where it's at here. Right. I gotta shut this down. Okay, there's Commodore 64 projects, bounce and ball. Okay, got it. Back. I'm going to try to load it into here. Remember how to do this. Raw data. Sprite pad, 64. So right there it is, Sprite. So there's the Sprite data. See how fast we loaded it in there? And did you see what I did? I just imported it there.
Yeah.
That's where we basically gets, and you can see all the PRG data and everything, but inside of here, when you export it, I have to create, like, I could just pretend I'm doing a new one, I guess. Export it. Here's where the memory address is going to be. This is where we were getting that 16384. And the hex for that, since I cannot do hex in my head, 84 is 4000. So he had to set the 4000 like that. That's how he was able to load that instantly in the memory. And then when you run that bin thing, I guess I don't want to erase this one, so I'm gonna have to rename this or something. I went over right here the file. So I'll just call that Sprite 2. And then when we export it, we change this to 4000. And we save it to raw data so that we can get those bin files. PRGs for basic, raw data for semi language. And then, oh, that's right, I gotta save it here. Actually, I should go back here and change it just to show you. Just change something in here. I don't care what I change. So, multicolor. Just make it look like it or something. Doesn't matter what it looks like. Yeah.
But you're basically saying that the starting address was baked into that file.
Yeah.
So I did a sprite without the file.
Uh-huh.
And the way I got it to work is I set the start address to be where the default address is for sprites. 8192. So if you go to your mapping to C64, look up address 8192.
Sure, give me 1 second. I want to run this way. 8192, I have that book open right here in front of me, actually. So let me just pull the PDF back up here real quick. Where did I put it? Oh, we loaded it up. It was 8142?
It's 2000 in hex. It's 8142 in decimal.
Right here somewhere.
I'm sorry, 8192.
Yeah, right here. So it's inside the basic program area.
Yes, so if you scroll down, it is where it's the default area for the sprites to start.
Oh, I see it there now. sprite data blocks right there. User defines character dot area. Yeah, that makes sense. So I guess, are you trying to like animate it now or something? Like change the shape data?
I was trying to add more sprites and I couldn't.
Okay.
And I couldn't figure out how you were setting that address. You know, how you were pointing, how you were setting where sprite. So you did that for sprite 0. I tried to add sprite 1 in addition to sprite 0, and I couldn't.
Got it. Okay.
I couldn't figure out how. So what I did is I started a new program, and I put both. I started the sprites at the default area, and then I was able to have 2 of them at once.
That makes sense. Here, I'll show you.
On the program here. So yes, you've changed the sprite. Now add another one.
Okay. Well, we need to. You could do a couple of tricks with that actually. You can turn on more than one sprite. I need to look up the memory address again.
So I was able to yes, have 2 sprites on the screen that had the same data, but I was actually trying to load 2 different shapes, 2 different sprites.
Okay, so we need to create them. So we need to create them here. So I don't know what you want to create, but.
And I was not using the bin file. I was just using the hex data of the sprite. You know, as you would do in a basic program and have your data statement sprite.
Yep. I'm gonna make something really weird here, and then we'll take a look at that. What happened to this? Okay, it's weird. It wouldn't let me. So they operate in 64 bytes. So we need to count out 64 bytes. Hex 16384. We don't have to use 16384. He just used that for purposes. We could use the regular. Like basic, for example, uses I think it's 832. If you're not going to create a whole lot of sprites. At least. Cassette buffer, I think it is. I think it's 900. I can't remember what it is now. This doesn't really matter. We can use anything. We just don't want to use something that's already in use. So 828, yeah, that's it. 828 to 1019 is the cassette IO buffer. Let me get the full screen back up and show you where I'm getting that. Switch between. I keep forgetting it's over here. So 828. Right there, the cassette IO buffer. That's a safe place to use for sprites. These are basic pretty notorious for doing that. So we could use that. Of course, I got to reload both of the sprites in that area again. Otherwise, I got to load them in memory, and I don't have to do all that. So what's the hex for that? C. That would be the first one. We'll just call it sprite 1, sprite 2, or ball 1, ball 2, doesn't matter. This is ball 2.
So I couldn't think. So what I wasn't getting was that the bin file had the address, the memory pointer already set in it. So you guys weren't doing that in the program. So in the program I made, I had to set those pointers. So for sprite 0, I found memory address 07F8. and I put a 128 in there. That was sprite 0, and then the next one is 07F9. There I put a 129 in there, basically saying, you know, next block.
Yeah, it's done a little bit differently.
And I was starting at that address, that 2000 in hex, which is the was it 8192?
Yep. Just gonna load this in and I'll show you. There's the two sprites. If I did this correctly, it should read them both correctly. So we just have to go back here. We have to also load them both in here. And you probably already figured out these are the loading memory addresses.
Yeah.
The trick is to point it to wherever you loaded that raw data into. Or just hash. And
so does that one bin file has both of the sprites in it now?
oh, yeah, it'll have actually both of them in there because they're both one after the other. But I have to load them both in. So I won't see them both. Let me just break out of here again to make sure. Yeah, something went wrong.
Yeah, you loaded it into basic. Started at 821, which is
Oh, that's why they use 832.
bytes into basic.
I wonder if I could do this. I'm just curious if I can do this. Let's see how it's working. It may not work. No. Oh, what did I do? Oh, I switched the pointer over. Okay, I see what I did. So I switched from here, so I needed to do these outside of this. That's what I forgot to do. Thanks for pointing that out. But I got two memory addresses. I don't need this one. Like that. Why is it still doing that?
I thought you put it at 4000. You didn't put it at 832.
I saved the new ones. I put at 832.
Well, 832 is inside of where basic runs in the C64, so there's probably stuff already there. I used in hex. I used 2000. Right.
2000.
Yeah. And then I use these, and then I use these other addresses to set a memory pointer. So there was a 07F8, which is the 2040, the sprite pointer address. 2040 and 2041 is where I put 128 and 129. Which I think I must have found this in. I think I found this in one of the books I was looking at.
For a second.
That's exactly what I was getting whenever I was trying to load two sprites. I never could find the second.
That's the asterisk there. We're working all over for the asterisk. So this is why, because it's only pointing to 693, so we have to make it point to 2000 or whatever the hex is for that. What is that extra
2000 was the hexes where I had mine.
So it's pointing to decimal 8192. So we need to point to 8192.
Yeah.
Which
I think the book that I got this from said that was where Sprites started in BASIC.
Yeah, I'm pulling that up. I got that in front of me right now, actually. Quite love having the book. See, Sprites 3 bytes wide, 21 lines high. Okay, that's understandable. Sprite 0 starts at address 704, 11 times 64, continues for 64 more bytes to 767. I did just show you an example of this book. A value of 11 in 2000 indicates a shape data for Sprite 0. Oh. They must have started this book example at 693. I'm just trying to understand what these numbers mean. 63 is the size of the sprite. Well, what is the 11? Is that the page? Probably the page. So I'm trying to figure out what this 11 is for. So the value in 11 indicates that the shape data for sprite 0 starts at address 704.
Sprites are 40 bytes.
Oh, that's why that, yeah, that's what I was doing wrong. I was using 63. I don't know why I was using 63. I was thinking the 0. I was like, no wonder it's supposed to come there. It is. There's a 704. Making sense to me. So value of 7 indicates the shape data for sprite 0 starts at address 704 and continues for 61 bytes to 767. So we have to shift it to point to 8192. If you multiply this by 255, you'll see how many memory addresses you can only go up to that many, which you might have saw that number earlier on the screen. Hint, hint. Remember the 163 we saw earlier?
Uh-huh.
How it's calculated. That's how I knew that the sprite data was there. Because when you peaked early in the 2040, 55 multiplied by 64 is 163.20. We went 8192. It's about halfway, isn't it? 8192.
Right, but I found that confusing because I did not know that that was baked into that bin file. Right, so you're loading the bin file. Now you're going in and looking at the address back end to say, okay, where does the bin say it's going? Whereas what I was doing here was I was explicitly setting those pointers in code, which I think I think that's a little clearer, right? It's just obscure to have it in that bin file where I can't see it, right? And how would I, if I wanted to move that sprite, how would I move it?
How would you move it?
Yeah.
And how would you move the animation?
No, the where it starts in memory. What I think the answer is I would have to go back to SpritePad and export it again with a different address, right?
Well, there's a couple ways to do that. But you want to be able to move two different sprites with two different shapes on the screen.
Yeah, and I have an example of doing that. I can show it to you.
Okay. I need to make some room. I got everything bumping into my camera over here. My back is pressed against the TV here, so I'm going to move some stuff out of the way. So, what I need to do, first of all, before we do that, we need to get this loaded. This right back here on the screen. Because we never set the correct memory location, it's not pointing to the right data. So even if you cycle through this blue, I don't know, you can kind of look at it.
Yeah.
You can see it moving all through the memory data that's in memory. You saw the character set in there? Because we're going to do the common character set.
I did something similar whenever I was looking for mine. I had it rigged to the fire button. So the incremented one every time I pushed the fire button.
So, right. So I'm just trying to test to see if this data loaded in correctly.
Mm-hmm.
I don't think it did. You see the character set there?
Yep.
Okay. That's actually the common SQL character set being loaded in memory. I always thought that was a cool trick. I gotta do this. But it didn't load it. I'm going to have to resave the sprite data again. Make sure I used the right hex address. 832, because earlier I used 828. 840 is what I wanted to do. And also, we can also do more than one sprite, so we could do this too. Just copy this one. Oops. You might already know about this, but it's it. Not letting me click in the box. Not letting me paste it in there. I'm just gonna load in some of my old data. Let me just jump out of this. Otherwise I should know. I have other sprite examples I can get to where they are. Let me just write import. I'm not creating one. Import, yeah, means I'm pulling it in. Okay, so raw data. Here we go. Because I don't know if you've seen it, I was working on the game for a short time on here. Scroll map vertically. There we go. These are all that kind of stuff. Like here's a sprite set for aliens. Here's a sprite set for characters. If I open this, here's my characters. Change the colors. Supposed to be like these. So like that. See my sprites?
Yeah.
Okay. So now I got my sprite data, so I can load this into, we can use this as an example, and load this into our program, which is exactly what I did before. So I'm going to, I have to copy all my files over now. I'm just going to copy all of this. These are my maps, by the way. They're used for character pad, sprite pad, which is another whole dinosaur that you can load in giant maps and everything, which I demonstrated live on YouTube before. Okay, so now I need to copy these over to my header folder. It's back here. We have two. We could do the aliens or we could do the sprite. The aliens are kind of cool, so I'll just do the aliens for now, I guess. Got this right. 8,000. Original one. Is that the default or something?
We've had trouble hearing you. Really?
Stop so I can put them back on the screen. What's wrong? Down. why I didn't find it. Oh, wait, this is a different file. This is a raw file, and this is a bin file. This is bin files on. I use raw files. I don't know much of a difference. They're kind of all the same size anyway. Ready 2 sections here. We have a range on. Why did I use 8,000? That's 32,768. So the year is 2000, right? I'm safe.
Yes, I use 2000.
Okay.
Can you hear me?
Yeah.
I'm having trouble hearing you.
Can you still hear me?
There's a lot of noise.
I turned my volume all the way up. Okay, so I need to go back to where this was saved again. So it's in I guess. Now they're at 2000. That's next. Twit, that's why. Two is $32 is too high, right?
I used 128.
128? Is that it?
and I put that into 2040, which was the Sprite 0 memory pointer location.
Oh, that's going to be too high. I looked about pointer height bytes for the 8192. So this one, 7968. This one says 82 to 24, so it's a little bit over. So we got to back the low byte down a little bit. See where it's 22. Like 4 or something. 8192. It was 0. Sensitivity is 0. It's 0? Really? So 32 and 32.
Look at 128 in there.
128?
No.
64 times 128. Why isn't that showing up? You loaded them. You saved them. Or did I save them? Wait, did I ever save them? Well, let's open up a different one, I guess. Okay, no project. Okay, so I want to import. Yeah, that's what I use. We'll change, we could change colors here or there or whatever. It's easier just to change them here so you have to change their code. I think this black area was yellow. That's green. Yeah, that's green. You need to put a different color. Like that. I can do that again. But sometimes if there's an error in Sprite that it doesn't. Anyway. So we know we saved them. It links to. Otherwise, it won't find the files. There he is. It. I just have to turn on the multicolor. It doesn't turn those on by default. I don't have my maps in front of me, so I don't know what is what right now. Now you can see them. I can see the sprite on the screen. And you just shift.
What address did you use there to enable that?
Huh? How did I do that?
You used 53.2.
Oh, what number did I? Oh, I went here. I'll pull it back up on the command board. It's 53276 sprite multicolor registers. I just turned on the multicolor. Is all I did. Because if you don't, it's not going to show all the bits.
So I did that by setting it at, what is it? 53.269.
53269.
Yeah. To enable the sprites.
Oh, enables. No. This what I did is I turned on multicolor, so you can see all the colors. Which somehow your program did that already. We're going to change the size of the sprite here.
Did I?
I do not have these memorized anymore. I used to have all of these memorized when I was designing this game. I got slammed pretty bad for it because it was a bad scrolling game, but it's a scrolling game. I don't know if you've ever seen that, but we've done that for months. This is a bigger sprite.
Cool.
Now that we have them on the screen, we can do whatever we want with them. Two. Pretty in 131. I'm going to set up a pointer. But it's working. Oh, where did I get that? 6. That's weird. So, a little bit. So that's what you want to do. You said you wanted to do 2 sprites. So they're all here. We just need to define them. 3, 2.
The next one would be 127.
Got it. Well, I'm trying to figure out where the next
The next memory pointer.
2.
Yeah. So I.
53,269.
In 2041, I put in a 129.
That's what I was trying to do. We need to enable 2 sprites. Well, we already have 2 sprites by doing that. We already have that enables 0 and 1.
Okay, yeah. To enable 2 sprites, you have to set the first 2 bits. So I loaded a decimal 3, which would be
3.
Yeah,
0, 1,
1, 2, right? Is 3. Turn the first 2 of the 8 bits on.
It was in 120. We need the second one here for the next guy. So 127 was it?
129. And 41. So 40 was 128. And 41 was 128.
I think it's 120. What's this? 132, 133.
That looks pretty cool.
So to change the multicolors too. What was that? 53 to 80. What is it? 53 to 87 through 53 to 92. 53 to 94. Those are the sprite color registers. Or what do that actually is? Basic, and we could just convert it to assembly. So we got this color defined. It's how you break out the basic, but here so anyways, we need to get the guy on the screen, so what's the colors on this guy? When you change for one sprite, it's going to affect the next sprite too. Now we need the next guy on the screen, the shape data, 132, that's good. Right here. He's going to be right on top of the other guy. We'll move his position. Find those already. I already did it by default. So we need to how you can peek into these registers. Some of these you can't peek into if they're not in line. The 100. The vertical. Should be down somewhere. Earlier, what am I missing? There, why is it showing up? Oh, I know what it is. Oh, wait. I should have tested it first on the screen to see if it would show up here. Do that. Where is he? Unless he's not in sprite 0 and 1, maybe he's a 2. But anything we change in this is just going to change this guy. And the other guy. He's sprite 2. That's why. Find sprite 2 apparently. We just have to fix the data for the other guy. Does that make sense? Did I lose you again?
I'm here.
Oh, okay. Did that make sense what I was doing?
Not really.
No. let me get the sprite turned on and I'll show you what's going on here.
You're doing a bunch of stuff in Basic now.
Code again. So I turned on 3 here. If you look at that memory location, 53269, bit 3 enables sprites 0, 1, 2, and 3. So apparently when I copied them in the sprite pad, this data was set for sprite 3, not sprite 2 like I thought it was, or 1. So that's going to tell you which sprites are displaying, and this is just basically pointing to where that sprite is in memory. You saw me play with these numbers here earlier. Those are just basically going one memory location 64 bytes to the next one, 64 bytes, and so on to get to the next one. 4 times 130, that's where that sprite data is located at. 64 times 32, that's where that sprite data is at. When we do it in our code, we actually have to point to those memory locations and shift them using that 2040 and 2041 to get them to show up. I just wanted to make sure I got it working in here. What I like to do is actually go through and get a basic program example working and then kind of convert it over to machine language or simple language. So what I need to do here, so I got the I need to turn on the multicolors for the other guy. 3, 2, 8, 7. Christ. Three, 2. What did I say was 76, was it? 76. So if you look at 53276, you have to set it to bit 3 because we're using 3 sprites. So 53276, which I did not set it here, I just noticed. So we need all the multicolors on. There's the multicolor. He's facing the wrong way, but at least you saw the multicolors on him now. Just because we just need to point to the data that walks in that direction. 34 and 35. 34 and you're good to go. Oh. Actually, just did it. 134 to 133.
I had a different address for enabling, right?
Greater than 135.
See, I was using 53269.
You using what?
53269.
Oh, that's for enabling the sprite. That gets them to show up on the screen.
Right. What were you trying to do?
276 turned on the multicolors. And then 2040 is what points to the data in memory. Going back over this, is there anything that you need an explanation on how I did this, or something that doesn't make sense?
Oh, so what was it? You said, yeah, so 53,276. Is that what you said?
Yeah, that's the multicolor.
For multicolor. Yeah, I had that in my ball example, but I put a 1 in there, but I only had 1 sprite in there.
Yep.
So that you're saying you put a 3 in there to do 2 sprites, like I did for enabling the sprite too. I also put a 3 in there to enable.
Yep. It just turns on bits 0, 1, 2, 3, or there's 0 to 7 bits. And inside of those bits there's 64 bytes that's loaded into the screen. This is how big the sprite is made up of all the characters. We can convert this over to.
So the values that we poke into 2040 and 2041. Those are the memory pointers. Not quite getting how.
You're kind of going out again.
The 2040 and 2041, the sprite memory pointers.
Yeah.
I'm not getting the value that we poke into there, how that connects to the address.
How that connects to the memory address?
Right, because we want these to start at that 8192.
Uh-huh.
So we poke in at 2040, we poke in a 128, and at
well, let's go ahead and do that in the example. I guess you can use our code now. Use mine since it's pretty similar. So we need to get we'll just get one of the aliens bouncing around, and we'll try to get the other one just appear on the screen at least for now. So the first thing we got to do is we got to load in the shape data, of course, which we already know from our program. It's 130. So I just 130 stored in 2040. That guy on the screen. All's right, it should load him in this time. It should. Got this is good. It should show up. There's our alien guy. Oh, multicolor. Turn on the multicolor. It's easier for the viewers. I just explain. Wait,
yeah. So where did you get 130 from?
Oh, that's where the sprite was defined. Okay, that's what you were asking me.
Yeah. How do you calculate that?
I didn't get my program back up on the screen here. Let me just go now and break out this again.
Because I have a different value that I used for mine.
Okay. Yeah, I'm gonna go over that here, so I just need to break out this one again. Yep. We got him on the screen, and we got him in the same language. So if you peek into 2040, you can see 130 is where we already know that's how the numbers are. So the 130 is how that's calculated. That's what you saw me probably doing earlier. But like, what the heck was he doing earlier? I was calculating low and high bytes to see where this memory location falls at. 11. There's 128.
Came up with 130, and I'm looking at 128.
128. Okay, so basically you just add this to 130 and you get the 8320. This is how the high bytes, probably understanding of how high bytes and low bytes work. That's going to be like a whole tutorial itself.
I think that's what I'm missing here, because one of the other things that I want to do is I want to be able to go directly to a 16-bit address, but I can't figure out how to do that.
We're happy to start.
Registers.
Yeah, let's start with some examples. I'm trying to think of an example we could start with. Trying to figure out the easiest way to make this possible.
Can I walk you through what I got here so far?
Yeah. Go back to your screen.
Yeah, put the screen over me. I increased my font. Can you see it a little better now? It looks pretty good. This is my writing. This is also where I'm reading the joystick. So I've got the joystick moving my targeting reticle, and when I hit this fire button.
So you do have 2 sprites on there.
Right, so I got 2 sprites in there, right? What I don't have is the most significant bit, so my X gets cut off.
That's 53 to 69.
All right, so if I walk you through what I'm doing here, I've got my sprite data at 8192. And what I think you're saying is that yours was slightly different. Because I'm putting in 128 here at the pointer to enable sprite 0.
But that's not where your shape data is at. Is that where you saved it?
Now here's the memory pointer is at 2040. I put in a 128.
But
that gets me this 8192. I guess I'm not understanding how the 128 gets me this address.
That's why I was going to go to the high byte, low byte explanation.
Yeah.
Before.
So you got a 130, right?
Uh-huh.
So I take it that you're starting at a slightly different location than I am.
Yes. I'm starting with 64 times 2. 128 bytes ahead.
2 is 128.
Yes, I'm starting 128 bytes ahead of your sprite. Because each one is 64 for the sprite data.
So here's where I enable the sprite, and that's where I'm turning on 2 sprites, so I put a 3 in there to turn on bit 1 and bit 2. And here's where I set the first memory pointer. It's kind of magic to me until I figure out that high-low byte rate. I set the sprite color here. I'm not using multicolor sprites for these. These are just one color. And then I start their locations off, X and Y. And then here I'm doing the same thing basically for sprite 2, although I'm setting its location to be 0, 0, which is off screen, until you would the button to read it. My main is all it's doing is reading the joystick and then jumping to the raster. I put in these routines from the other one, but I couldn't get them to work. And I actually had some interesting things happen with this read joystick. So initially I had these commands, move left, move right, down. I had them immediately after all of this stuff. But when I did that, it wouldn't compile. And what I eventually figured out is that these branch equal.
Yeah.
There's a length, like a number of characters after them that I'm limited to. So I can only have so many commands that can be reached by one of these branch equals.
Yeah, you can't branch past 127.
Ah, okay. So I guess how I got around it was I just moved this code sort of out of the way. And there happened to be
and then condensing your code, you can just set a table and pointers and stuff too. That's a little bit more advanced, but or you can just set a jump labels. I've done that.
I would like to be able to set up a table, because the other thing that I was trying to do here is I started trying to draw the bricks for my Breakout game,
Oh, that's cool.
and I ran out of room, or you know, this is where so I start here at the beginning of screen memory,
Mhm.
and after X overflows 255, it all goes wrong, right? It just starts wrapping around. I can't get any further down the screen. What I would like to do is I would like to be able to have, I guess I'm going to need 2 bytes, right, to be able to hold a 16-bit number. But I would like to be able to store directly into a variable, I guess, an address that I can set or change, right? So rather than have a 24 here, I would like to be able to have that say, look at 2 different bytes that I can then set with values that it would jump to, right? It would put those 2 8-bit numbers together for the 16-bit address. Whenever I was looking at books,
Pieces of that we putting up there.
yeah, so I looked at a couple of examples with books, and they had this command that I couldn't figure out. What is it? LDA? Or no?
Actually, that's a good example to use.
Yeah, they were trying to load like an address, I think.
Yeah, that's actually a good example to use. Let me see if I have a program example. Maybe that'd be better to go over it. I'm just going to open up another copy of CBM here. I don't think this one. It's so long I didn't know if I even have this in here. Open project. So leave that example up there. What you have the 2.51. And I'll switch over to my screen. Can you still hear me?
Yeah.
Okay. Can you see my screen, or is your screen still up?
I can see your screen. There's like a little guy running on.
Yes. So this was that game I was working on. I don't have to go selected, but it's a great example because it uses the high and the low bytes. And for kind of example, use that instead of trying to. Actually, this might be a more complicated example. This is actually explaining how pixeling scrolling works. Here's a good one now. One of the common things to do, this is a great example to learn, is how to clear the screen. To do that, we need to access high and low bytes. So this example you have is perfect on the screen. I think, isn't that what that does? It's a block fill. Yeah, that's actually a pretty good example, actually. But this was the one I used right here. So
I couldn't get this one to work. There was some command in here that wouldn't compile.
what?
Yeah.
Looks correct to me. Light fill 251. You just have to load the high and the low bytes. Other than that, everything looks normal to me. You didn't put the colons before the labels, did you?
Let's see. Actually, the one I was trying was called Spiral Fill or something like that.
Spiral fill.
If I still have it.
Well, here's what I wanted to show you. Do you see this right here on my screen?
Yeah.
Do you see these numbers here? 8 times 256 equals 2048 plus 6 equals 2112.
Yeah.
So this, we know, is a memory location for a screen coordinate. So if you put 2112, comma, a number, it's going to put something on the screen, on the comma 64 screen. Actually, this might be off the screen. Let me see. Let's go back to, as an example. I got the program up here, so I'm going to switch back over to the other one here for a second. There's too much stuff on here. Slow that down. I'm going to just pull this up so I can just pull CBM, C64, so I can explain something here again. while I have this up on the screen. So you already know that 1024 through 2040, 2023 is the screen data for the size of the screen, which is I think 999 bytes. But when you're clearing the screen, you can only go up to 255 bytes. So as your cursor scrolling here, it's only going to go up to 255 bytes.
Right.
Past that, you have to put the high byte, which is why I wanted to show you this code right here.
Okay.
Which is the whole purpose. We probably just have to write an example. I think it would just be better just to write an example and work from that instead of trying to explain, because I have a lot of stuff going on in mine here, but we'll just start anew. Alright, way too much stuff open here. I need to start closing some stuff here. I'm going to start closing all this TV Studio and stuff. Why is this still open? Okay, there's this. We'll just close this one. We'll just save this. We'll just start a new project. Their screen's good. Write the assembly file. We'll use this as a starting point, right? To create a screen. So, first thing we want to do is these locations. Let me expand this. You see this 251 and 252?
Yeah.
These are safe places in zero page to store data without it writing over anything important. And they're just not being used by the computer itself, the keyboard or whatever. So 251 would be the low byte, and 252 would be the high byte.
Okay.
So probably the thing I like to do is I like to kind of load them in. You saw I put a 64 and an 8 in here. So we're going to change that to represent what the screen is in low and high bytes. So if we go over here, we divide this by 256, it will tell you the first digit for the high byte. Just divided by 256. Actually, that's the low byte, I'm sorry. Let's see, 0 plus 1, let me make sure I get this right. 0 plus 4. So 4 is, somebody's probably going to get mad if I say this, but they always get mad when I say it backwards. So I think 4 is the high byte, 0 is the low byte, if I'm not mistaken here. This first byte here can go from 0 to 255, and you can't go any further than that. That's
Yes.
as far as it's going to go.
Yes.
And then the second byte is the same, except when you get past this one, let me show you. Let me just show you an example here on the screen. We'll just use this for example. Set this to 255. 6. I have to do this. 0 plus 255 plus 4. So that would be the 255th location on our screen. Right there. To get to the next byte, you have to take this 255 and move it back to 0. And this one is going to shift up to another byte, which would be the next one in line, which would be 5. Does that make sense? See how it changed to the next number?
I don't get how those two numbers that you have in what is it, the two places you stored them on the 0 page. I don't get how those two numbers cause the screen to reference the number in there and draw what's in there.
It's because the first value, and I'm probably the most horrible person to explain this to somebody, but the way I've always learned it was this way. First, the low byte is always going to be from 0 to 55 in the first hooked location.
So the screen starts at 20 or 1024, right?
Yeah.
And if I do a store 1024 and I put in a 255, right, as X, that'll only get me so far.
Yeah.
How do I get how do I store a bigger number than 255 in that 1024 address?
Well, you can't store it into the 1024. Remember, the 1024 is only going to take 255 bytes at a time.
So the way that I'm drawing on the screen is I'm just writing directly to that address, and then I guess then I have an offset, I guess, from that that's 255. So the other thing that I was thinking was that I could just, instead of starting every time at 1024, I know that that's where the first line starts, and then I could have another value. I actually started to calculate them out where I wanted to draw them. So it was like 1264, 1304, 1344. I kept on offsetting by 40 each time, and that basically gives me another line, right?
That makes sense. So you're kind of just storing them into their locations.
Yeah, I was storing them directly into the screen memory.
And you can do that, but if you want to understand high bytes, that's why I wanted to show you this, because when we run this clear screen,
so ideally I want to put this in a loop to do it, right? And I want to be able to programmatically change that address that I start at, right? I want to be able to do it at an arbitrary number. So I think what we're doing is right. What I'm not getting is, you had two variables or 2 bits in the 0 page that sort of come together to make your 16-bit address. And I'm not getting how that is coming together and how you will reference it.
All right, I got something else I was going to show you. I found it's actually in the same book, the Commodore 64 book. So let's switch back over that. Maybe it'll be easier if you see it instead of me just trying to explain it, because I can be really bad at explaining stuff sometimes. We're going to the book. It's on page the introduction here. So it should be right here, actually. Can you see my screen now?
Yes.
Okay, let me make sure this is good. So bits and bytes. Right here is where it starts talking about it. So this is how all the computer is made up. This is what we were talking about earlier about the bits.
Uh-huh.
It shows you read through here.
I understand an 8-bit number, but what I don't understand is how in machine language, I got an X, I got an A, I got an accumulator, which is an 8-bit, I got an X, which is an 8-bit, and I got a Y, which is an 8-bit. How do I jump to a 16-bit number that I can calculate somehow, that I can not have hard-coded in here, but be able to manipulate, add numbers to,
You wanted to know about 16-bit map.
Mm-hmm.
Okay, that's what they did.
I need to be able to write to a 16-bit address that I can calculate, that I would be able to calculate 16-bit numbers, using 2 8-bit pieces of RAM.
So, as an example in BASIC, you are at memory location 1024. Let me see your example. We just had something stored in here. You wanted to be able to read the next location over here next to it, or even the location down here underneath it, and so on and so on and so on.
Yeah, I kind of want. Yeah, so I want to be able to put bricks, kind of, in the middle band of the screen there.
Up and down the screen.
So I started off at 1024, and then I can offset to 255, but that's as far as I can go with the X register, right?
Yeah.
So I want to be able to, I guess, not hard code in the 1024, but be able to increment that starting address that I am storing to.
Okay, we're heading in the right direction. Then okay, now I'm just make sure I understand. We can do that with this example, actually.
Yeah.
So let me
This is what I was talking about. So you've got 251 and 252. Those are your 2 8-bit numbers that somehow are coming together to allow you to jump to that address, right? As a 16-bit address, not as 2 8-bit numbers.
0 plus 4, what's it? Yeah, 0 plus 4. 0 plus 4 is 1024. So what this is doing right here is this storing in this location right here, 251. This just understand we're using these for high and low bytes. So this would, for example, this would be the low byte. High byte. It's always the number after is going to be the high byte for the 16-bit, as you said.
Okay.
Everything keeps popping up on my computer now. This is the 16-bit number. Because this number is going to reflect where we want to draw on the screen. So I think I'm going to shorten this loop here a little bit so it doesn't go too far down. Otherwise it's going to crash. I'm just going to load in a simple value to start with. Hopefully it doesn't crash on one. And we're going to loop through it so we can draw. We're going to try to poke in 1024, 1025, 1026. And this is the trick right here. So this is going to be the data that it's going to store in the 1024 plus x, which is this number up here. And this increment x is going to increment through this. So I'm going to have to change this loop a little bit here. I got the y leaked in here now. No, I'm sorry, I'm doing this wrong. The y, because the y is where you want to. The y is representing the low, the x is representing the high. Get myself confused here. Y we just set to 0 since we're not going to change the 0. And then the x register is going to be the high. So 0 should be right. Increment right should be yes. I'm going to coming out some of these other lines here for now. So we can just focus on, and I already got it right there, you know it right there, so we'll be oh, I knew what I did here. Confusing myself. What I did is I preloaded these before so we could store a high and a low byte, so it would get the memory that we can ship in memory to get to the high bytes. And then these down here, I already got the X and Y register loaded. I did that. So I have it shifted in. We're just going to start it at 1 instead of doing that. This is 0. So let's just see if we can at least get that to draw on the screen so I can kind of go from there. Because otherwise, if I do it wrong, it's going to do something really crazy. It's going to try to like fill the entire screen. It might even go into memory. Because keep in mind, this 16-bit number can go anywhere from 0 to 6535. And it means you can poke into any one of those locations in memory, wipe it out, basic, the whole program, or whatever. So you have to be very careful when you're putting in the high and the low bytes. So I'm just going to run this as an example to see if I can get this screen to clear an error message here, probably because I didn't define this because I turned this one off earlier. What it's saying is I can't find this label, so I guess we'll just have to erase this for now. And come back to it. What did I do wrong? Oh, my comment. There's a way to default the screen size every time.
You.
See that? So it didn't quite do what I wanted, but it still passed 255. You count them, there's actually more than 255. So it's going from 1024 to whatever this line is down here. It's some weird extra data there too. We need to see something here. Here's a little bit here. There's that thing. Yeah, it wasn't putting it. It was just something left on the screen there. So it's each of these is 40 rows. So we count 40 times 1, 2, 3, 4, 5, 6. 40 times 5. Add the other 200. So probably did quite do it. 1, 2, 3, 4, 5, 6, 7, 9, 10. 1024 plus no, it wasn't. That was actually up here. It was actually 6. But it actually did go back to 255 because this would actually be 240. 1, 2, 3, 4, 5, 6, 7, 8, 16. 40 plus 16. I'm just going to see if it went into the highway. It did. By one, look at that. This last digit here was actually the highway, which is probably a good example. And how that's working is this loop here. So what this is doing is it's filling in memory locations 251 and 252. I can show you even here with this data. So if you go back here, peak in the 251 and 252, you see a 0 and the 4 in there. And what you don't see going on is the X register. So what it's doing is it's starting this at 1024, and this X register right here, or I'm sorry, the Y register is incrementing through whatever's stored in 251. Remember we started that at 0? So as you increment through Y, you probably get this part, it's going to be 1025, 1026, 1027, and so on, right? That's when it starts drawing all the stuff on the screen. It's just incrementing till it gets to the end of that Y. Now since Y can only go to 255, it cuts off right there. So I'm probably off on the data. I've got to count the 0, because it goes from 0 to 255, which is actually accurate. So to get past that, though, we have to do this stuff down here. But I wanted to make sure this part was clear first before I went into that. Does that make sense?
Are those parentheses needed?
Yeah, this is how you access what's called the indirect Y in zero range. Yeah, the parentheses. Are you copying on your example or something?
Yeah, I think that's what I was missing was the parentheses.
Yep, that's the only way you can access it indirectly. So now you can start shifting out the high and the low bytes. And that's what this is going to do down here. You might figure this out. 252 is going to flip the high byte wherever, whatever's stored in 252. And earlier we stored a 4 in there. So as it starts incrementing, it's going to start shifting the next high byte in memory. So as we go through here, we could do an example. We could probably just do this one here. And then 252. I think that might be the next. We just load in them. I'm just trying to change the data that's on the screen. Let me just try that. Probably do something really weird. Don't trust what it's doing there.
Put a spade up there.
It's putting that 1 in there. It's not really there. See, it's not there. It didn't work. It didn't read the next byte. I wanted it to read the next location and store it, but it didn't read my data. This is why the X register has to come into play. I guess we couldn't do it that way. I thought we could do it that way. So we'll just take it in by 1. We're going to need that D Y back on the screen. This is where it gets a little tricky.
I'm kind of lost with that branch not equal because you're not making a comparison.
Well, what this is doing is it's saying this branch is not equal to 0 yet, because what it's doing is it's looking at the last register on the screen. This is looking inside of the accumulator. And right now, what we're doing is we're actually, this is probably a bad example. I put decrement X register, but we want to increment the X register because we actually started it at 0, 4, started at a 4, and we started at a 1 here. So if we decrement it, I think that's right, it'll go back to a 0. And it's comparing it. Once it's at a 0, it's going to stop. If we don't, it's going to run into an infinite loop and it's going to crash the program. So the trick here also is to make sure. Do you remember where that dy was earlier? I knew I was going to lose it. Was it down here? Alright. Anyways, I think it went here.
Oh yeah, no, I don't remember where your label was.
I don't know where it was. Get some real funny results. You never want to branch back to an X or a Y either. You'll go into an infinite loop because your increment X will never be able to change the value because it'll always be stuck at the same value you started at. Well, let's see if we can get this to shift and then we'll go back into some more explanation. If I can get that next byte to show up. It'll probably go all the way across the screen and we'll probably go. Why did you keep doing that? Is there like something on the screen? Am I missing? Let's run this again. Let's see if there's something.
It's putting a spade up in the upper left corner.
That's right, because it's not writing over that. Because it's not reaching those locations where that one spade, whatever is there, the colon. So this was incorrect. So dy needs to go to. Oh yeah, it's running down here. I need the other one up. I hope I left it up here. Maybe I did. Oh, there it is. Okay, so it's at the Y register. That's right. One more above. Work this time. I'm ready to hard code in 147 in the memory and just clear the screen every time you try to do this. Alright, let's see what happens. It did something though. Did you see what it did? It didn't read the high byte, but it basically put whatever 252 is whatever was at 251 and 252 at the very end, stuck it. So what it did is it basically took, because it was still stating that there was a 0 and a 4 in this, and it was able to stick that back into 252 somehow. It didn't work right. Probably because I stuck the 65 in there. Let me take out that 65. Maybe I should have stuck in there. I was trying to get it to change data halfway down the screen without. I'll show you. Anyways, if we change this number, this is going to make it go farther down. I'm just going to be reading that many more highlights. You notice it went farther down this time? There's a lot more lines on the screen than there were before. Did I lose you?
Yeah, I'm here.
Oh.
I'll
put it back up. So earlier we stopped somewhere around here. Now it's going past the high byte. I just wanted to show you this as an example.
Yeah.
And that's because we changed this one. So it's now incrementing the next high byte. So in 252, what it's really doing is saying, I need to calculate this again. What that is again. 1024 plus 257. So the 1281 is, it's probably 5. So sticking that next, remember there was a 4 in here earlier? In 250, remember this is 251 and this is 252 where we stored them. And earlier this started with a 4 because I can only read the 255. Notice this, I put a 5 in here and it goes to the next value because anything above 256 is going to get the high byte. That's what this did down here. When I incremented this, it shifted whatever was in here earlier, 4, to get the next high byte to a 5. That quite makes sense?
I'm trying to figure out how I'm going to get this to work on my code, and it's not coming.
Of course. Well, these are great examples to start with.
Yeah.
What I started with was Beginner's Guide to Machine Language, and actually, I might have a PDF on here. That would be a great book to even read and start with, actually. I prefer that book. Let's see if I have it here still. It's a book I read back when the days of visiting libraries were common, before the internet. And I fell in love with that book. Because I could only check it out so many times, I actually would sit there in the library and read it. Because they had a limit how many times you could check out a book. So I would sit there and read it for like hours on end. I was like, one of these days I'm going to own that dang book. But just kind of a little story there. So anyways, I need to get to the PDFs, which is right here. Machine language for beginners. I think that's here. Watch me not have it. I have it here. Okay, just about to download and then we're bound to. should be. Don't want to see it. Don't see it. Gotta be in the section.
What was it called?
Machine language for beginners.
I've got assembly language for kids.
No, I had that book too. It's a brown book. I thought they had it on here. They definitely got to have it on here. I'm losing my mind tonight. I see everything else. You know what? Some of these aren't loading. That's why. I knew something was wrong. I'm like, wait a minute. Now I've seen it here so many times before. Okay, where's the language right here? Okay, so the other one's loaded, but the one's now these ones are. Oh, these are. What is this? Well, this is something new they added to it. Unless they took it out of here. Okay, I just don't have to do a quick search on it. Let's just open here again.
Who's the author? Do you remember? I totally despise being trying to take over everything. Never. It's a compute book. Let's probably it right there. There it is. Right there. That book. They have a PDF. That's a good book to get. Right there. A great book. Let's see if I can find a PDF for it. I want to buy it. It's probably over there somewhere. Find it. Somebody's got to have it. Let's do this. I just thought it was here. Well, at least we can look at it right there. This will teach you all about high and low bytes. This is what I started with to learn about screen clearing. And this will teach you from low bytes, showing the low bytes there. And then it goes into an example of high bytes. It's really good to read this example. Send me that link. Or paste it in the chat there. And I've pasted in of my program for the bricks.
Okay, cool. You have a separate section for the raw data. Cool. So do I download this or do I copy this?
Just copy it and then create a new file in your project. And I just called the screen test.
Screen test?
Yeah.
The wrong button. Okay. And go to cancel again. And you have the raw data separate.
The raw data.
At the bottom here.
You don't need that. That's the same thing. You got it.
Okay, then I'm good. It's right here. Thank you. So getting back to the book. right here. This is a really good, it's best to just kind of just start right here. It says Y machine language and kind of read from there. This will teach you all about, I mean, it's kind of a lengthy book, but it'll teach you about basically what these Y registers do and stuff like that. It's a really good example to understand, you know, how the computer sees memory and stuff like that, and how hexadecimal works. This is where it starts talking about the high level. Like actually, these are the bits turned on and off. And here is actually an example right there. 0 through 255 decimal, and it talks about it here. Let's see what a high example is. 2 bytes together to form the address. Yeah, I think that's it. Where's their example? That's their code example. This is quite a bit right here. Yeah, this is where it's talking about zero page. This is what I was doing earlier when I was playing with zero page. And this will talk about how to load into those next bytes. Somewhere in here. I'm trying to find a code example. This is just all the bytes. Oh, right there's one. Right there. So go to that page. I don't know what page that is here. It doesn't show me a page number. It's on addressing, and it's a scroll at the top. It's right after the pictures. So when you get to the pictures, you're getting close. And this is what I was basically doing earlier, is I was changing this Y to point to the next highest value. And then I was using, getting back to my program, I was using the X so I could have a separate register for the high byte so I could flip over to the next bit in memory.
And that's called indirect, huh?
Uh-huh. Yep, indirect Y.
Can we see if we can modify my brick program to draw all the way down the screen like I would want to?
Yeah, I'm trying to figure out how we're going to do that. We have to
somewhere. And I'll show you what I'm doing. And I kind of have an idea of how to do it with the table, I guess.
Yeah.
I guess go ahead and run that so you can get an idea, because it works for the first row. Because the first row is an offset of 160. You know, it's not beyond the 255, so it works for the first row.
But it's not going past 255, you're saying?
Right.
That's where we got to use those indirect Y to load it.
Yeah.
I did in the scrolling example too. Because to scroll beyond the screen,
Did you try running it? Did you run that? I can't see Vice going.
I don't see anything running on your screen.
Oh, you want me to run it? I thought you were going to run yours there. I was looking at your screen.
Oh no, I ran mine earlier. That's all I was going to show you.
Okay, here's what. Well, you've got my code now, right?
Oh, you mean the code you just sent me? I'm sorry.
Yeah.
Okay. Let me go run it again. I don't have files though. I don't know if I need the data or not.
There's no data. It's characters on the screen.
Let's see which one it is. It's this one.
Yep.
Okay, there we go.
Right. So it puts the red bricks in the right spot, right?
Mm-hmm. And you want to draw the rest underneath so far.
Yeah. If you go back to my code, around line 15 is where I started figuring out the actual. So I've got 4 rows of bricks I want to draw, and right over see 15 where I got it commented out there. I got the Z. That's where I was trying to figure out where on the screen each row of bricks would start. So those are the numbers that I came up with. But the way I'm doing it now is I've got that string, that SCR underscore LOC, the string location variable that I set at 160. And if you look down below, that is going to be relative to the start of screen at 1024. You can see 1024 hard coded in all of my routines. down there to draw different bricks.
Down here.
Yeah, so you see there where it's storing at 1024 and then plus X, right?
Mm-hmm.
So rather than do it like that, I was thinking that if I could have a lookup table of those 4 addresses that I had up above at line 15, rather than using the 1024, I just want to start it each time at those different addresses. You know what I mean? And that'll give me my 4 rows of bricks.
Makes sense. I'm trying to see how
to figure out how to get that to go, and I guess what I'm going to have to do is I'm going to have to make those 2 things in the 0 page and then use the indirect addressing. Well, I'll have to set those 2 variables on the 0 page and then change that from the hard-coded 1024 to use the indirect addressing, right?
Yeah.
And get those 2.
So how many did you got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10?
Yeah, there's 10. But if you look down below, that is 2 rows of characters. You know what I mean?
Oh.
Yeah, kind of see what they're made up of. Yeah, there you go.
One underneath the other.
Yeah.
What we have to basically be able to do is this. Sounds like 1024. I don't know what screen you started. Let's just say we started at 1024 plus 40.
I've got the offsets there that I need on line 15. So that row starts at 1184. And then I need the next one to start at 1264 and then 1304 and then 1340.
Okay. Okay, so I wanted to show you something.
Actually, I think I need to increase those because I think that is each row, and each one of those is 2 rows.
Okay. Let me figure out what location this is.
It should be 1184. Okay. So then 1184, where we're going to start. So our X register or load X, that one is going to be our highlight, basically. Don't have all the keys memorized and keep hitting the wrong one, so equals, there we go. That drives me up the wall.
And then we know they're all 40 rows, so we're going to 40 times whatever X will be, actually this needs to be 184 plus X. Figure out the next one down. And we have to keep changing that each time. Get to the next row, and so on, right? That's what you're trying to do. Oh, actually, I did this wrong. It's 40 times X, my bad.
Well, I kind of know where I want each one to start, right? So I think I could just manually load up. Like if I could have a table of value. Oh.
Well, I mean, there's a reason why I'm doing this, because this is how they would be calculated when we use those 251 and 252. Keep loading this X register to change each time, so it points to the correct place in memory.
Okay, yeah.
And to do this for. It would save you a lot of coding and a lot of having to do all that, computing and stuff. So we have to get that into those 251. That's what I wanted to start with, working with that.
Yeah, okay.
The trick to get to a high byte, and we're going to go a little bit more advanced for anybody else who's watching this right now. We have to rotate to get to the 16th bit. But we also, it's probably better to use an example for this, which is why I left my other program up, because I had just recently learned how to calculate high bits because I did not understand it before somebody showed me. And it still gets really confusing when I explain it to people, but let me find the example in this code here.
Okay.
I hope this is the latest. Let me see. Those are, I don't remember where I put it. I just have to look and see. 4, 16. I need a second here to go through this. There it is. Right here, this is 16-bit math going on. This is it, rotate L. So rotate L is going to allow us to pick up a high bit each time. This ASL, this is math, so this is calculating by 2. Like, so this would be really confusing, but this is what I was just talking about earlier. So reason why I did this, to explain things, let me run my program and show you what I had it doing.
Okay.
I don't have my joystick, so I'm not going to be able to move or anything. But what essentially I'm doing here is I was getting, when I moved the sprite around, I wanted it to make it detect when he's walking over a character. This is how collision detection is actually done on the Commodore 64 properly. Because the Commodore 64 doesn't have any way of knowing the sprite versus the background data, because these are totally different links and widths of each other. And they're also, it gets into understanding how many pixels is in a sprite versus how many pixels is in a character. There's only 8 bits in the character, but in a sprite there's 64. So there's some math that has to be done to calculate it. That's the whole purpose of why he showed me how to calculate the 60-bit address. And I wrote a basic program to do this. I'm going to see if I can find it on YouTube real quick here. It's the best explanation that can really explain why I did this, and maybe explain a little bit more about how the high bits and low bits work and all that. And to get this to work, we'll need to do a basic example anyway, so let me just switch over here for a second. This was that game that was, you can see there's a lot of videos. So this one right here is the background sprite detection. It's going to pause this and let's do this a little bit. Well, you watch the demo here. We don't need to hear, but you can see what I'm doing there is I'm moving. Let me just let you watch it for a second here. Let's get some talking over here. Do you see where the sprite is there? Mm-hmm. It's over the background characters, and it's detecting exactly what's going on over the character. So when the sprite moves on the screen, it knows what the numbers are. And that's what I'm explaining in this whole demo here. As I move the sprite over, you see how it's changing the letters as I move the sprite there? It's picking up whatever's in that location. And what he taught me how to do, this guy on Limit 64, is how to convert it to Simi language to work. Of course, my example never worked perfect, but I get it pretty close to working. Do you see how it's moving and it's picking up the characters every time?
Yeah.
It's got perfect collision detection going on right in the background character. In BASIC, this is a lot easily to be accomplished, but in Simi language, this is a dinosaur. So I'm going to skip over to the code here now, because I explained it all. If you want to watch this video, you can watch it later and I kind of explain it. Down here is where it's calculated.
That I can look at that code.
This code?
Yeah.
I might have it on, I have the choice sometimes of not putting it on. I should put it on GitHub. I don't know if I did or not. I probably didn't. Nobody ever asked me to, so I'd have to give you a copy of the code. Figure out where I put it.
Can I get your email address?
Sure. I'll let them. I don't like to say it out loud to people.
Oh, okay.
I did mention it earlier on the screen, but I don't want to be spammy or something. I'll put it in the window, maybe they won't see it. So, in this example, you see how I got my game side by side with it? I did get it working in this, and I was showing in this how I got it working in the example, or I was explaining what I wanted to do. What I did is I first wrote the basic program, because he showed me how to do the calculation. He did the calculations for me because I couldn't figure them out. And then later, after I got it working, I ran the program side by side to kind of explain how you can convert this over to a Simi language. And if you look, I don't know if you can see at the bottom of the screen here, but it shows the characters as I'm moving over. It's detecting on my screen when I'm walking over, but it's not perfect. Some of the math was off and it was picking up some of the wrong data, because I'm also scrolling the entire screen. It's very complicated.
Oh, yeah.
So I also, while I'm moving it, I had to make him figure out how much the screen has scrolled and what am I now looking at.
Uh-huh.
He actually did. He wrote it really, this guy was really smart guy in Limit 6. He wrote an entire game that figured it out, and he's trying to teach it to me, and I was like, I'm not getting this. But this basic example is the best way to start. This is what we're going to be doing. To figure yours out, we need to figure out where the x is, and we have to subtract it from 40, which is the size of the length of the pixels. Let me just stop this for a second.
Yeah, the 40 characters across the screen. Yep.
And you have to divide it by 8 because there's 8 characters in each character, or 8 bits in each character.
Each character, yeah, okay.
Same with the y. We did the same thing with y. Then you have to add it to the 1024. And to do this crazy math you see there going on. I had to kind of shift my bits around a little bit because I put it in the center of the screen there to get it to work. That's how your example would have to be too. That's the way I'm thinking it could be done. That is doable. We'll just have to start with the example that you gave earlier. But that's why I need to leave this on the screen, because we'll basically be using this rotate, because we'll need to track where the high bit is so we know how to calculate it. What this is doing is it's keeping track of what's in the high bit. Well, it's actually, if I'm not mistaken, I don't think it saves in the accumulator. It's calculating it, but it doesn't save it. So we have to save it somewhere or it'll lose it every single time. It doesn't stay there. It only stays in the accumulator. And then I'm storing it down here in a label so I can figure out what to calculate it off. And I did the math right here. But if you look at the basic program example, it's almost the same here. So I'm calculating 11 times 2. I probably didn't do a good explanation on this, but this is basically figuring out, why did I do this?
Those are your shift lefts, huh?
Yeah, right here it is. So I'm figuring out 21 is the length of the sprite. I think that's the length or the height or whatever. And divided by 8. That's what this LSR does. This is dividing. Which Bo got wrong last time because he thought this was the multiplication, but this is really dividing. So if you do 3 of them, 2, 4, 8, it's dividing by 8. And then this is going to subtract next because we have to subtract 21. But here I did 5 because I was trying to get my screen data lined up and it wasn't lining up right. No, I did it right here. I'm sorry. I subtract 21 right here. So I subtracted 21. I saved it in the Y. And then later, I'm not sure why I subtracted 5. I think because I was playing with the program trying to get it to line up and it wasn't lining up. But does this make sense? It's subtracting this from Y here. And then it's going to, let me just show you what this is doing. This is just divide by 2.
That's a shift right?
Yep. By 4. Divide by 8. So each of these is going to divide by 2 each time.
So why is that an L and not an A? I thought that would be ASR.
No, it's left shift right. It's where it's shifting in the accumulator. Is it shifting to the right or is it shifting to the left? ASL, accumulator shift left, and then LSR, left shift right. It goes the opposite direction. So if you're going to the left, then you're multiplying. If you're going to the right, then you're dividing.
Yeah, I don't understand any of the math yet.
Yeah, the math part takes a little bit to get grip because you have to also. What I found out I had to do when I go in Vice each time, you probably saw me doing this last time with Bo. I had to learn how to use this monitor because I had to basically figure out what was going on with my math all the time, so I could figure out exactly why it wasn't getting the data. And eventually, I got it to figure out where the math was working right. But if anything is off on your math, it's not going to work. Something's still wrong with mine because it doesn't work, and I kind of caved in after that after it became so complicated. But if I run this, I think I need to find my joystick. I think I have it unplugged here. I'm going to plug in my controller so I can show you what I'm talking about here. I don't trip over my camera here.
I liked your example where you just had the square sprite going across the characters that were the alphabet.
The basic one?
Yeah, can I get that somewhere?
Yeah, I'll have to find that code.
Okay.
I need to plug this in. I I finally put my computer in a perfect spot where I can get to it and bump in everything else. Okay, so I got my controller plugged in. I don't know if it recognized it or not. I'll have to rerun it. I'm just going to run this and see if it recognized my controller and kind of show you what I'm talking about here. So, see how he's moving and the screen scrolling? Now, the whole idea, darn, is this the wrong example? What it's supposed to do anyways, it's supposed to show the character as he's walking over here. This probably isn't the right program, but I have so many different examples of this. And it's going to show as he's walking which character is in the background based on those calculations. Of course, this one's all screwed up now. Something was wrong with my scrolling on it. But that's essentially what this is doing right here. Is this is a, I forgot what this 11 was for. Let's see, 11 times 2, 11 times 3.
Is that the width of your sprite?
It might be, I don't know. It's probably better to find a basic example. So let me see what I go back to the basic example. What did I call this? Let's see if I named the program so I can try to find it on my computer somewhere. Get right where the code first shows. Sprite at character position. Okay, so maybe if I can see if I can find it.
Was that was you wrote that one in BASIC, right?
Yeah. Because this was too complicated to do in assembly before I understood a little bit of how to do it. And it's the best way to do anything. So you're on the right track by writing it in BASIC, and then
Yeah,
you can
that's where I'm
it.
at. Yep. Start
I
with
think
what I know.
I think that's how the pros do it too. I've always done all my games that way. Okay, so what am I looking for? I'm looking for this.
Sprite at position, I think you said.
Okay. I'm just trying to figure out where it's. I've organized all my files, so I should be able to find it. It's got to be in here somewhere. Anything's probably right in here. This is where I stored all my CBM stuff.
I need to take a quick bio break. I'll be right back, Steve.
Oh, me too.
Take 5.
That sounds good.
I'm back.
All right, I'm just trying to move some stuff out of the way.
I got to get some caffeine.
I couldn't even move around my room. The wires stretched all over the place.
I was up at 6 a.m. I drove down to St. Louis today and back. My mom was up from Florida.
Oh, Florida's a cool place. That's a long drive, though. Okay.
About 3 hours.
That'd be exhausting, and you still want to do this. That's pretty much dedication for me.
I'm pretty tired. I'm pretty fatigued, man. So that's the only thing I was going to say is I think that I might not be getting this just because I'm just tired. I may need to look at it and really absorb it, when I'm mentally.
Yeah, especially that book that I recommended. And then find that code example.
Yeah, thanks for your email address. I will be sending you questions and examples as they come up, I'm sure, if that's okay.
Yeah, no, that's totally fine. I need to find this example. What was it called? Character at sprite position.
I signed up on Programmer Mind. That's your website.
Yeah.
I signed up for the forums and looked around, but it looks like it's just filled with spam.
Yeah, there's something wrong going on with it. Ever since I've done those forums, I've been attacked so much, and I need to get that fixed. I've been trying to get people's attention, and I started doing the forums, and all of a sudden I just got spammed to death.
Yeah.
I couldn't even get rid of it. It was so pathetic. And then I'm getting emails from, GoDaddy, and they're like, you're spamming us. And like,
oh, really?
Yeah, because it's messing up their servers.
Oh.
They keep track of your bandwidth and all that. Okay, anyways, concentrate here. The program.
Sprite at position, was that what it was called?
Yeah, what was the date of that program? Let me see. Sometimes if I can date them, I can find them that way. I should have their date in this stuff. This was on October 2013.
I think it's played forward to the next video already. I don't think this
did? Oh, wait. It was running this whole time. People were like...
Yeah, I think we were in the other... Yeah, that's the one there. What's that? Sprite background collisions.
Okay, so we should close to it here. September. Now, the other thing is this is a D64 file, so I need to figure out where that is. It's one of these... actually, down here, I got some examples. Sprite at character location. I don't know if you can see my screen, but I'm looking at... It might be down here. This is where I was learning how to do it. Actually, I got some code examples here. This might be it. Try to put this in and see it. Well, no, let me see. Wait, is this it? I think this is it. Let me paste it in this for you. Actually, is it pastebin.com?
Yeah, that's it right there. Was the top link.
Top one. I do that right?
Yeah, I just hit at the bottom there. There's a button that says create new paste. Just hit that.
I'll create new paste. There it is. Oh, so I have to create a new one first.
No, it created it.
Oh, it did. So
yep.
Where's the link down here?
It's up in your bar.
I just think to say that. That's right. What is that?
That's how they support that site, I guess. With some crazy ad that plays in the middle, as big as what you're looking at.
Oh yeah, I know all about ads, and I know all about affiliate marketing. I wasted a lot of money on that crap. I spent over $400 in affiliate marketing. It didn't do me nothing. So people who do that are really knowing what they're doing.
Is your YouTube page monetized?
It is. Yeah, I don't really get a whole lot from that though. I don't have enough views. I mean, I think probably now I was thinking about that earlier. Reason why I don't have views is people are confused the heck out of what's going on, probably. But how's he doing this stuff? Which is why I started these Hangouts. Of course, last week we got a little bit carried away, but I think we're going off to, it's kind of cool because we're starting off on a good example. let's build a simple game, and let's build upon it and learn concepts as we go along. So I think, did you see if that code will copy in there and run? Because you should be able to just paste it into.
I'm sorry, I was chatting with you, and I'm getting it now.
Oh, okay. Oh. Meantime, I'm going to see if I can find that other example while you're doing that. Just take this one out.
Would you call this sprite at character?
Sprite at character position. Why am I doing this? I'm going to create one to open. I'm going to see which one of these is the right one. I've made so many of these. This whole game was like a space game. There was like aliens walking around. You could shoot them. That's weird stuff. But
Oh, it didn't compile. Hang on, I think Pastebin mangled it or something.
I did it. This. Well, this is my real original version. This is really old. Yeah, this is like my first version.
There's no basic tokens.
Okay.
Well, here's what it did. Not quite.
That must be when I was first testing it.
Close.
Well, you also have what the heck? Where's all that? Okay, let me try to give an example.
You complained about this line, so this may have been mangled somehow.
Let me see. Let me see the code again so I can compare it to this other one I just pulled up.
Oh no, it looks like it's mangled in your notepad too.
I think I just found it. Let's see, that one has 250 lines. No, this one has 250 lines too. The only thing is I didn't draw all the lines on the screen. It should have drew all the lines on the screen. So where is the loop? This doesn't have a loop in it. So these were just the notepad examples, and I need to find the original code, I guess. It's probably one of these right here. So time to get C64 Studio up again. And load the disk image.
Attach.
That's cool how I remembered Lodestar from the last time we used it. Okay, find out where this is. So it should bring him up right there. I think this is it. Character under sprite, I'll bet that's it. What do you think it is? Which just looks like the biggest one. I can just do the first one, I guess. Nothing there. That's not even it. That's like the earliest versions of it. Apparently it wasn't that one. But this is before my organized days. Let's figure which one it would be under. Actually, this has got to be it. I'm not getting the right name. Probably one of these. These files are bigger than the other ones. Sprite BK collision. That's probably it. Close. Let's see some data again. My joystick is not working. Why not? Got shut off. Huh? It's still on.
Could you not pick it from there? Where it says none, you couldn't put gamepad?
Actually, you know what? Let me make sure. Where do you see gamepad?
Go to joystick settings. At the top there.
It's not showing. Probably have to plug it back in again or something.
Did it not say gamepad up there?
No. I think I know what it is. It's probably because you have to close it out and run it again. I don't know why it does that. To have this example, I could probably use this one. No, I can't. Crashed. I guess it was in there too long and it crashed. That's what it was. I reloaded it. I don't know why it does that. This one's just kind of redrawn. I think this must have been like when I was still testing it. You see, it took me a lot of programs to get it working. Not be the right disk image. Thought it was.
There's one in there called Final or something. Do a list again of your catalog.
I don't know. That might be it.
Sprite something Final 1.
Oh, I see it. That's probably the one. You're probably right. Yeah, I have a habit of doing stuff like that. Putting the word final when I'm done. Like everything I do. Oh, that's it.
Awesome.
Nice job. Yep, that's the one you need.
Can you copy that? How are you going to copy that listing into Program Studio?
I'm going to have to do this. See if I can remember this. Create snapshot image. Save snapshot image. I think that's it. I think that's it. It's not save quick snapshot. I think that's it.
And then you can open that in CBM Studio.
I could do it this way too. This is what I did before.
You can copy out of Vice? Oh, I didn't know that.
Yeah.
Oh, but it didn't get.
Doesn't get the whole lines.
It only copies what's on screen. Huh?
Yeah, it does. It's bad. How did they do that? The heck? Nothing here. Should just add new lines. I don't know what it did. I was just trying to list 0 to 653. Okay, I put paste. That was probably my fault. It does the spaces and everything, so it's very, very particular. And the readies and everything else in between.
And it wrapped it too, so I'm gonna have to fix that.
It wrapped it?
Yeah, so you see
Oh, yeah.
line like what is that, 230 or 200, yeah, right there, yeah.
Okay. I should be able to paste it in now. When I get back to the end, paste. This should have it now. I need to put that on GitHub. Yeah, it's too old. Who cares now? Now. The program's like over a year ago.
Well, I use GitHub. That's a good place to put code.
Oh no, I mean it is, but I mean this example would be dumb just to go in there and put a new paste on for GitHub because I'm not even working on this anymore.
What's your username on GitHub?
That's a good question. I haven't used it in so long I totally forgot. I have to look it up again. But lucky for me, I always put it in one of these. So it should probably be on this. Nah, it's not on this one. It's probably on one of the other ones. I'll bet it was on this one. That's not a GitHub example. Oh, wait. One of these will have it. I'll do this one.
There's my GitHub.
Oh, cool. Thank you. It'll take me a moment to find mine.
I can start. I should start putting some more stuff up there. Everything I have up there now is Arduino stuff.
Let's see. Let's see where I would have put it. Oh, here's Google Drive. Once somebody asked me for one, and I put one in for. It's called a repository. Let me see if I have that in here. There it is. That's when I first started putting it out. Somebody's like, "Can you put that on GitHub?" And then I created this. There it is. Right there it is. Got a picture of Metal Warrior, my favorite game.
We'll star that one.
So how do I do? I just star yours too?
Yeah, you just follow me. I think.
Do I just click this star?
That would star that particular project.
Oh.
There's a way to like follow someone, isn't there? Yeah. See the button that says follow there? It's a green under the sign up.
Oh, okay. Oh, I have to sign in mine. Oh, good thing you remembered mine. Okay. Yeah, this is when I put all the code up from before. Well, I guess one here I couldn't hurt to add the other one, right? Well, I have it here. Now I can remember how to do that. I did create a new.
I use the desktop application to create new repositories. Yeah, I guess you can do it there. It's gonna want a local path for that.
Local path.
Well, this will just create the repository. Then you'll need to load the repository.
This will allow me to paste the code, though, right? Which is what I want to do.
I do it. I clone and then synchronize. I'll clone down and then I'll make my changes and then I'll do a push.
So what did I do wrong?
I don't know. I don't use the website for that. I use the desktop app.
Oh, okay. I'm just trying to remember how to use this crazy thing again. Barcode.
Oh, there you go. Oh no, that's someone else's repository.
That's one I just created.
Well, that's importing into yours. It's asking you for a link to import from.
That's not what I want to do then. How did I do that? It's been so long. I created it by clicking on this. I remember that. This is it. It was here somewhere. Now if I can remember which one was the right one. It was this one. It was this one. We have to create a name for it.
I don't know what a gist is.
I don't know. I just knew it allows me to create grid data when I do it. They're all right here. See all of your gifts. Oh wait, did it not say that? Public guest. What does it want to now? Description? Let's do one. What is it looking for? File name including extension. Maybe it wants it down here. 110. That would be a good place. I totally forgot how to do this. Put it in there twice. Heck with it. There, it's in there twice. But that's how they can access it. They can go here, and they can access all my gifts. Gifts, obviously that word, which are basically the files that it creates. These are all examples I had from before.
Yeah, I've never used the gists before.
No?
No. I use repositories.
Repositories allow you to basically load it directly to your desktop. So you don't
Yeah. So I've got a local folder that has all of these. So if you look at my screen, once I create it, I'll go here and you can download it as a zip, or you can get the code to clone it. There, this is where it is, and then if there's like a command prompt. I forget what the command is, though. I think it's like clone. I think it's like clone, and then you go.
So it kind of does the same thing, except it puts it on your desktop. That's interesting.
There's a
The shell, somebody showed me that before. I couldn't figure that thing out. So I just started doing the gist. So that they're accessible online to people. I mean, the ones on the desktop, are those only accessible to you?
Well, no, anyone can go to my repository and pull it down, and they can actually change and modify it and do commits.
Wow, nice. I'll just see what you had on here. NeoPixel lamp. There's your breakout game. Or forget I need to save this somewhere.
Yeah, so I created that, and then there's a button here to set up in desktop. Here it shows you the command lines that do it. So I can just hit a button here to get it set up in desktop. I got the desktop client, or from the shell, you get here to do it too.
That's pretty cool.
Now it's going to ask me where it's at, and I don't have it anywhere.
For what is?
Oh, let's see here. Now if I put a file in here, oh, I did it twice.
I think we put it on a pretty good show tonight.
I think so.
I think people got everything right. Started out kind of weird.
So now you see that I've saved that file there in my local.
Yep.
So now to get it up to GitHub, I just hit publish.
Oh, nice.
And if you go to my GitHub now on the website.
So that program's called that you used. Is it Get Desktop?
Yeah.
And you get that on the repository, I mean, on the same site, GitHub?
Yeah. Whoa, funny.
You have a cat?
I do. Can you hear?
Yeah, I can hear him.
You know, I think I didn't commit it. That's the problem here. Let's see here.
That was one of the cats, and I'm cautious about the shedding part.
So my problem was I didn't commit it, so I need to commit it to the master. There we get it in, and then I can publish it. Oh, she is 20 years old.
20 years old, that's pretty old for a cat.
That is an old cat. There it is. So now here's the program.
No, you got it. Study it with
And
style.
if you wanted it, let's see here, you should be able to, yeah, well, I think if you look at it, there should be a option over here to clone to desktop, maybe. Mine says open in desktop.
I've had to refresh the page.
You can download a zip, I see. What else was there?
I don't see anything, I just see copied path.
See the little computer screen by the pencil? What's that? What if you hover over that, what's it say?
Open this file in GitHub Desktop.
Yeah, try clicking on that.
Probably gonna ask me to download. Yeah, nothing's showing up actually. It's not doing anything really. Opens up a link and it goes away.
Yeah, you probably doesn't know what to do if you don't have it installed.
Do I install it up here
I don't remember.
or github.com probably? Let me check that right. Just guessing. What's it called again anyway?
What was it called? GitHub Desktop, maybe? It's just called GitHub and then Git Shell.
GitHub desktop. I'm just driving this tonight. Simple collaboration from your desktop. That's it, right?
Yeah. There it is.
I clicked on it twice. So this saves you having to go to the website.
Yeah.
It'll take a lot of time with it. Do you have that before I forget, do you have that screen copy example right here? You want me to create a paste bin for that too, for the clear screen? So you can kind of study that.
And this program didn't quite work the same way as it did for me as it did for you. I got this weird stuff on the screen.
It didn't work? I'll go back and check it again.
Yeah, what happens when you run it on yours?
Give me 1 second here. I'm going to give this to you real quick.
Oh, you know what? I never grabbed it. This is the other one. Never grabbed yours.
Oh, the original one, yeah. That's why I shut mine down.
You need to go back and get yours.
Here's a screen copy or screen clear example. You can play with it and see if you can get it to clear the whole screen. Or clear the screen. We were filling, or see if you can get it to fill the whole screen. That'd be your homework assignment. It has something to do with the X. Which you probably already know.
No, I can't. So when I go to yours, your repository is empty. How do I get to those gists?
Is it empty? What? Nobody's ever told me that.
The char and sprite repository. So you put it in a gist, and I don't even know where do you get those at?
Are the other ones showing up? I'm curious.
Oh, gist. Here we go. No,
That's how you spray it. When you click on the one on the top scrolling four-way, does that bring up anything? They're not loading, then I did something wrong. Nobody ever told me anything. They just let me go.
Where did you saw a bunch of gists though, right?
Okay. It's there. It looks kind of funny, doesn't it? Yeah, I just copied it. Let me just double check and make sure it got saved. Trying to do two things at once here. I was trying to. Did you get that link for the clear screen?
Got it now.
All right. to refresh it, see if it's still there. Oops, I went too far. Oh, never showed it. It's never got saved. What the world? I just have to paste it in again. I don't know where it went to. Or code. Set up in desktop. Maybe I can use this now. Do it right. So I have to set up a folder for it?
Yep.
So I need to create one.
You could, if you want, you could just point it to your CBM Prg Studio projects.
That's where it is right here. Oh, really? They come down and take a look at all this stuff?
Yeah, it's going to make a folder inside whatever folder you pointed at, though, which is what I learned doing mine. So mine's. So,
do I need to set it up or make it match what's my GitHub login? I don't know it by heart.
oh, I don't know. You only do it once, or I only did it once. I don't know. I don't even know what mine is.
I think I'll just have to wait for that because I have my passwords on my computer, but they're all in one place. I can't show that on YouTube.
No, you don't want to show that on YouTube.
I would close that out. But I put it in Notepad and it's closed.
Yeah, paste bin it like you did the other one, so I can grab it there. Then I'll put it up on mine.
Okay. I left it open here. Pretty sure this was it. That's right. This one.
Try running it first in Studio.
It's already open in Studio.
That's just, you loaded it from Vice from a disk image that you attached. I'm saying make a new basic file in Studio.
Oh, Studio. Oh, okay. I want to see this was it. This is it. There you go.
It says possible spam.
Possible spam.
Yeah, if you look, look at your thing there. Something triggered. You need to hit "I'm not a robot," I guess.
Oh, so I need to do it again?
No. I think that's it there. Yeah, you just needed to hit "I'm not a robot." Now I can see it.
Came up the same number. Reminds me I need to fix my website too. Gotta do that one day. I used to work on it every week.
Huh. That is that's the same one that's broken. You see that what it looks like on mine?
It's almost like they're doing the shift lowercase or something. Is there a shift lowercase one? I think I can remember how to do that. Let me look at my combo again.
What you just pasted into Pastebin, put into Studio and try to run it.
I did. I pasted it into mine earlier. You mean from the Pastebin? I'll click on the one you clicked on.
So yeah, copy that.
And then I'll just have to reload this.
Studio. Well, you can just close Vice. Close Vice.
Oh, I can still get it from here. So I have to paste it.
What? No. Paste it into Studio.
Oh, okay, that's where you're running it from. Okay. I might please device. It should work directly in device. So I need to try new project.
I just been putting basic files in the same project.
Got it. Did I do this right?
Yeah, just hit create.
And then I have to add it as a basic file.
Yep. Now paste it and run it. Here we go. Now run it.
That's where you're doing that. Yeah. Weird.
What the heck?
Some setting in your device or something.
You know, I think that the link was the link wrong.
We did.
What the heck?
Make sure it wasn't in lowercase.
Try pasting that one more time. I don't know what's going on.
Run it again.
What?
Something go wrong. Compare the code. Is that the same? Probably look at the bottom part. Well, actually, the top part where the A strings is. That's the letters. Does it miss anything?
No.
Weird. Run yours again. Did I see it? Large it. It's almost like it's doing your control characters or something instead of the characters. Those are your control characters. That's really weird. I have feeling Bozer, he'd know what's going on. He's a very smart guy. So code looks the same. It's something to do with the display. It looks fine to me. .190 is what's determining what to put on the screen. A lot of the 190 is correct. That is really weird. There's way too much salt in these. I got the lightly salted peanuts that are still burning my lips. That is very strange. Is there a character set setting? You want to compare your settings to mine? I need to move your screen over. I can't see it again. So probably the main ones are the ones that's highlighted.
So I don't have video cache on.
You don't?
Or double scan.
That changes anything. Not much else to do with it. I stay away from some of those stuff. I will mess you up. I changed something at one time and I could not get it to work. I had to reinstall the whole thing. I don't know what it did. It was like changing the screen all weird. I'm like, no. What basically I was just trying to do is get the screen, the resolution to stay big on the screen. So I just started messing with everything and it got all screwed up. All right, I'm not gonna mess with it anymore. Although there is one you can do current settings to specified file. I know that you can like load it to defaults. There's one called set default settings. Have you tried that? You might just leave the size of the screen or something. It won't hurt it. It'll just kind of put it back the way it was. If anything was changed. See if that changes anything. Nope. This is a mystery. It's like the numbers are showing, but the character data is not. Almost like it's getting garbled, like from a semi-language standpoint, it's not passing in the correct binary bits to switch it over. What they call that, bit masking or whatever. I don't know. I won't go into that, but that's basically shows you how to put numbers on a screen in machine language, and that's complicated stuff. Which is something I need to learn. I wrote an example of an Atari computer before, but I converted it over. Somewhere in those books I got, I'm sure. It's very strange. Try changing the numbers. I mean, because the letters, all it's just picking up is they don't have to be A, B, it can be anything. It's just going to pick up whatever's there. Maybe make an uppercase. Something changed.
Something changed?
Yeah, the first part did. I'm going to look at your line 190 again. XC plus 17, 14, plus 2. Minus 13 the position. Otherwise, see if you move it over there, the M is going to be way over there. Can you see my screen?
Yeah.
See where the m's at now? That's why I use the minus. It's not lining up right. So I subtracted it to where I thought the screen was at. Apparently it was 13 and it worked. So actually all that's doing is this is positioning it. That's not the data. The data is found in the print page strings, because that's what prints everything in the string on screen. Maybe try changing the string number. I don't know. It's like your string table's messed up or something. Try using a different variable. Well, earlier you were running. Have you ever thought maybe trying to exit out CBM and trying to reload it again? Because you were changing something in BASIC earlier. You were showing me so that you could rerun the program automatically. Remember?
Yeah, look at it.
Maybe it did something where it relocated the. What's it doing? Oh, weird. Yeah, it's doing some weird stuff. I'd probably jump out of CBM and reload it. That's an easy fix. That's what we do at work when the computers don't work. We just reboot them. Make sure it's saved. You might even have to copy it in again. Make sure all occurrences are closed. Fingers crossed. What in the world is going on? Did they erase it? Oh no, you just put the line below. I see what you did.
Yeah, but you see, I mean, it's coming over from CBM as that character, as those characters.
Oh, I see what you mean. So even when you look at the data, it's looking. So you have to go in there and change it. Okay.
Why would I do that? I want it to be here.
Well, see if you changed it in there. See if it would run right. Just out of curiosity.
Oh, you know what?
But
Let me do this. So what do you have up here? What is AA, BB?
just have repeating letters. That's it. The sprite would fit.
I guess it was Pastebin mangled it.
Really? You got it working. How weird. Maybe we can get back on to what we were trying to do. I was going to see if I could get these to line up one after the other. Do a couple. I could test my luck. Okay, let's see. We got the shapes. Now we need to load the shapes here. Should be right here.
Why is this setting A twice?
Why is it what?
Why is it setting A string twice? You got it setting this A string on 25 and on 50.
I don't know why I did that. Let me see if you take out the one line, what does it do? I'm going to find
The
out.
first one, this one does nothing. I don't that I know of. I don't know.
I don't know how to break this thing. How do you break out of this thing?
I hit escape.
Like when you're trying to do listing, you can't break out a list. Okay, so if I take out the 25, I have no idea why I put it in there twice. It doesn't need to be in there twice.
Oh, I don't know.
Yeah, it doesn't need to be in there twice.
I got an illegal quantity error.
Yeah, because you went probably too far. To 255, it's not set with a high byte.
Ah.
I tried to set it within range like that.
So now we need to fix this so that it can go all the way over.
Yeah, I think we want to get your example working in a semi language. So
Yep.
got that. I'm not gonna bother with that one. All I did was that just to pass over to be able to write the code in assembly. So I'm trying to see if I can get this. I'm modifying this example of a clear screen and trying to get the shapes to load into memory. I'm getting an error message though. Oh, it's the byte thing. I forgot. That's what you forgot. See if I can get this to load those lines like you were doing. And we have to calculate by 40 each time as we're moving down the line. I don't know if you can see my screen.
I can, yep.
So right now all it's doing is just going across the screen. What we want to make it do is say only go so far over here, and when we get to however many you're drawing them out on the screen, like you have them in threes or whatever, then we want to drop down to the next line. This is good because I wanted to do this in my scrolling example too, because I really needed to get a better scrolling example routine instead of doing the cheated way I was always doing it. But this has to happen inside of this because this is where all the high bytes start happening, is right after this B and E here. So somewhere in here is where we're going to do that math. Bitmap. We'll also have to remember what's going on each time it's calculated. So now we want to calculate it by 40, which is why you need this other example. Do I still have it open? Oh, I closed it already. I need to close this one. Now we got this, I'm just going to close this one. That's magic. It wants to save it every time you close it. And then go back here. Is it working for you otherwise? Other than going beyond the boundary? I think it was this one.
Yeah, it's working other than, running out of.
Okay, cool. Oh, now I was going to forget the name of it. Okay, so it's right here. So here's where it calculates 40. So we have to make it multiply by 40. So we're going to need code like this. So we'll have to save these up here in its own memory locations. That's why I did all this at the top here first. So probably this code is a pretty good example to start with, because this is doing pretty close to what we're doing, so it's calculating position. So maybe it's not exactly what we want. This in here just kind of. Somebody got on me because I was saving everything in memory locations, and he says, don't do that. Save them to labels, or what they're called, symbols, like this. And then what I have going on in the program here at the top here, I have those pointing to memory locations right here.
Okay.
This is where all this is coming. Does that make more sense now? What we were talking about earlier, high and low bytes. Those are safe memory locations to use, by the way.
What's the Y8, Y40, Y32?
It's figuring out what's multiplying. Multiplied by 8, multiplied by 40, multiplied by 32.
So those are labels that you set up. So those are spots in memory that, like, variables that you created.
Yep. I'm going to put those up here. Try to look a smaller example. I should have never tried to stick it inside of my program. That was my problem. So I think we have them all defined here. So we have the high and the low.
And you're calling them Y not because of the Y-axis, but because that's the register that you're using?
Yeah.
Okay.
That was his example.
And
but this is just calculating by 8.
What's the 40, the 8, and the 32?
That's what I was just saying. This is multiplying by 40. This is multiplying by 8 in his example, and this is multiplying by 32.
Oh.
Our example to get the example he was showing me to get it working. So we won't need all those. We just need a 40, really.
So we need all of those spots in memory for his math routines to work. That's what you're saying.
We probably won't need the 8. I mean, one thing we're going to need is the
40.
Yeah, because we're only going to multiply it by 40. On the screen.
I basically do a row at a time.
That's what we're going to try to do.
Yeah.
This is where it gets hairy. This is where you start using the monitor and figuring out what the data is doing. He says it's not hard. I found it complicated. But he's been doing it much longer than I have.
Yeah. Of course it's not hard for him if he's been doing it for years. You'll have to see how to use the monitor. The only thing I've ever done with that is I've opened the monitor, and then to view the memory, then I go and I look at the memory address and the value. But the monitor itself, I don't know how to use. You know, it kind of gives you the command prompt in that window, and I don't know what to type in.
I put that in one of my examples. That I was going to do that eventually.
Okay.
So we were going to eventually go over that, but for now, because what I thought I was originally going to do is have people come in here and just be brain dead from the start and just take them right from the very, very beginning of the simulated language. But, you know, those people never showed up, so they're just going to have to watch. But it's good that you have more background, which is why you connected with Bo, too, because he likes that. I like one of his favorite sayings. He goes, try to keep up.
Yeah.
He could be quite a copy. So what we need to do is start a memory location. I'm using X in this example just because of the X position. Oh, I know why. I did X and Y, just like the basic example. Y is counting down by multiplying by 40. And then the X is just moving it over.
Right.
Figure it out. But we're not looking for the character under the cursor, or are we? Maybe we should use this example. But we're just going to concentrate on one thing. Let's just get the thing calculating, if we can get it to calculate down the screen, because I would love to use this in my scrolling example. Because I wanted to be able to make it figure out what's on the next line, and when I get to the bottom, I copy the data above it so I can scroll the screen in the vertical direction, which I got the vertical working, but mine's kind of choppy the way I'm doing it. I won't even go in there to kind of even debate and explain how I did that, because that's very complicated stuff. We'll stick with this for now. So in here somewhere, we first need to calculate. We probably should just do it in basic, or go back to the basic example again. I think I'm just going to write a basic example to do it. Why else would we not want to do that? said it started at 1184. Oh, wait, you already had an example. You gave me one earlier. Let me just go back to that instead of writing all this code. Let me see if I still have it open. I probably closed it. This was the assembly language version. Okay, so I'll just have to open up another one.
Yeah, the basic. Did I ever give you the basic version? I can give it to you.
I thought you did. Somewhere in all those paste bins. I don't see it here. I just have clear screen helicopter. Is it screen test? Is that it? I think this is it. That's got to be it. There it is.
That's the main language.
Oh, that's the assembly language. No. Well, this is actually perfect because. No, I'm sorry. We need to get the basic because we need to start there. That's right. No, you never gave me the basic example.
Here, I can paste bend it here.
I'm trying to figure out how to do this because yours is going to be the whole game. We just need to break it down into one simple section. Wait, I clicked on mine. Did you paste it?
There it is.
Okay. Yeah, so we need to kind of take bits and pieces of this code somewhere. I must have just saved it. I'm sure I saved this somewhere earlier.
I actually have figured out a better way to do it, I think. So I really draw the bricks. I really don't even need the Y because it'll just wrap around.
Yep.
I just need to change the color, toggle the color every 40 characters, or actually every 80, because it prints the top of the brick on one row and the bottom of the brick on the next row.
Yep.
The new brick colors, each brick is actually 2 rows, I guess.
And what's the name of the game?
Breakout.
Oh, it is Breakout. Okay. I'm just trying to create a file here so I can put it in there. We just copy the original Atari version. Cool. Okay, so I can see how you did it here. X%. Yeah, you did it exactly how I thought you can do it. So you calculated it just how we need to do in assembly. So this is what we need to convert this to the assembly right here.
Yeah.
Perfect example, actually. So I can probably just copy this whole section once I see what you did here. Yeah, but it goes up here. Well, I don't need to copy, I just need to mirror it, basically. So I'll put this over here somewhere. No, I do need to copy this. I'm sorry, I'm losing myself. We need to do this in BASIC. What's the percentage sign for?
Integer.
Oh, that's an integer. Okay. All right. Let's see. There's so many things going on over here. I need to close this. I'll just use this as an example. Here's going to back up again.
Yeah, you know what percentage sign should be? Modulus.
Look at the div and I pasted.
I had the same problem. So go to the raw paste data part of the paste bin, and that might work better.
Oh, really?
Yeah, so the top part is the formatted one, and then the bottom window, the raw one. Try that. Yeah.
That makes perfect sense. So I need to replace all this.
Yeah. Yeah, just Control A, Control V.
Oh, we'll do it. Why this again? close this out and do it again, or what?
I don't know. I ended up having to retype it, so I guess.
I'll just run it here. I got the code for it anyway.
There you go. So you see how I'm painting the brick. I do the top part of it and then the bottom part of it.
Yeah.
What would be more efficient would be to do the whole row rather than to do the top of the brick then the bottom of the brick. But my routine is to draw a whole brick, and then I just took that routine to draw a whole brick and then iterated across it. What would be more efficient would be to draw the whole row, draw a row at a time rather than a brick at a time. You know what I mean?
Yeah.
So I was thinking whenever I did it in machine language, I would do it that way. I wouldn't draw a brick at a time. I would draw a row at a time.
That's what the tables will do. That's what I was doing down here earlier.
Yeah.
With all this byte stuff I had. Wherever I put it. 20,000.
So my machine language version of that is not quite the same. It's not drawing a brick at a time. It's drawing the row at a time.
I'll just try to think here for a second. So if we're going to make this, because this is just drawing down the screen, and I moved this so it's at 1184 now. So it's 1184. So if I just run this for now, it's still going to just fill the screen. So it's going to fill it. Why is it giving me an error message? Huh? Invalid address. Oh, it's missing. Unless I got erased. I'm not erasing anything. Anyway, just run it again. All right. One thing I don't like about CBM is you can't undo anything. I just lost all that. I had to go back and go copy all that again. Have you ever noticed that? Anyway. Do you see how it's farther down the screen now? Did you see that? Or did I lose you again?
I'm here. Sorry.
Okay, you see I just started it further down the screen, so now we just need to be able to just make it. We also have to make it be able to split up, because yours isn't drawn all the way across the screen, is it? It's split up. You got like little holes in the center where the ball can pass through. So
no, actually, that just looks like it because of the way that, yeah. So go ahead, hit up on your cursor. You'll see that there is actually no space there.
You have a control character now. I got it now. Okay. That makes it. I thought you was doing that so the ball could pass through it or something.
But there is a top and a bottom to the row, so you do need to sort of alternate, flip, which draw routine you do, whether you draw the top row or whether you draw the top of the bricks or the bottom of the bricks.
I see. So I need to also see the characters you use for the bricks. Is it 48?
That's where, if you go to the machine language example, it might be easier to pull it out of there because it's shorter.
I think you got it defined right here. Red bricks, orange bricks, yellow bricks right there.
I thought you were talking about the character code that I was using.
Isn't that it right there? Green bricks, draw green bricks, draw yellow bricks. Oh, you have different numbers
The
right
character
there.
codes are like the 124, the 226, the 120.
Yeah. Right here. You have it right here is where it draws it. And you're just listing the stuff I can't. There, I finally got it right. So then I can see what you got 108, 98, 98, 123. So I can convert this over here. You just keep repeating those. You got different ones here.
Yeah, so remember the basic program is a little bit different than the machine program in that it's drawing the whole brick, whereas the machine language is drawing the tops of 10 bricks, and then going and drawing the bottoms of 10 bricks, then drawing the top of 10 bricks and the bottom of 10 bricks in a row at a time, rather than one brick at a time.
Makes sense. Yeah, they're kind of funny. Why did it do that? Oh, so you're using 160 as a brick.
No, that's just my offset. Scroll down.
Here?
This is draw brick top, so that's the top of one brick. It is 108, 98, 98, and then 123. So there's two on the, there's a left and a right, and then the two in the middle are the sort of the fill.
Oh, I thought this was top and bottom. Oh, it says, yeah, top, bottom.
Right, but on the top there's a left character, then there's two that are the same, then there's a right character, and then the same thing on the bottom. There's a different left character, two different ones in the middle, and then a different right character.
Let me see. Which makes sense. I just don't think it's drawing it right or something.
Well, it looks like it's just drawing the first one. It looks like it's just drawing the top left one, and it's not ever changing. But I think it's just drawing like the 108, and it's not ever going to 90.
It should be, because this changes the whole. Oh, I know why. Because Y is not changing. Oh, thanks for pointing that out. I want to point back. So, unless we're incrementing X, now how in the world are we going to do this? This is where we have to use that map, because you can't increment X here. We need X for the high byte. We don't want to change that on the shift data. But we could do this too, which you saw this in the other example. Transfer X to the accumulator. But then again, we're not shipping X, so it's not going to do TAY probably. Oh, actually, I think I did that wrong. TYA. Transfer Y to the accumulator, so it stores it in here, this accumulator part. And now it's just doing some weird stuff. And back to where it started. Oh, because I still got the shape. Don't want this line in there. Too tired here. I do want that line in there because we want to change the data. So I'm trying to get this to pass into here, but not into the Y, just so that it would change. All right. Let me take care of it.
We need another register.
There's no more registers. This is why the copy and the X come into play. So we have this thing here. Starts at the Y. This is what it's doing. It's always going back to this one right here to get the next high byte. But this is only going to DS, which is right here. It's never going there. I wonder. That was my fault. It was never reading it again. It was only reading the store. It was never reading this line. I only read it once. It should work now. Boom. Now we need to get them lined up. That's where the map part's going to come in.
Well, could make the data long enough so that we don't even have to do
What do you mean by that?
that.
You can add more of these down here?
Yeah.
Oh, okay.
You basically want to draw 10 brick tops and 10 brick bottoms and change the color.
What, 10? 1, 2, 3, 4, 5, 6, 7, 8.
Well, remember, each brick is 4 characters wide.
4 times.
That's why I'm saying you're drawing 10 bricks, right?
And how many are there wide?
They're 4 wide, so that gives you your 40 characters across.
I mean, how many bricks are across?
There are 10 bricks across.
So 40, that's where we get to 40. Okay, that's what you're saying.
Right. So we don't even have to, like, you can just keep counting, right?
So essentially, we need 40 rows, which makes sense because that's. I get what you're saying now. So we're going to need more of this, basically.
Yeah.
So 16 here.
The pattern will be different after 10 bricks, right? Because then you're going to draw the bottom of the bricks, and you need to go back to the top after you do 10 of those.
Oh, I was trying to draw like the top row, and then the bottom row, and then the next row, Yeah. I'm just already sure I'm doing this part right. And then once we get to the next row, once we get the first 40, then we're going to use that multiplied by 40.
Yeah, but your pattern's wrong.
What's up?
So you're drawing a whole brick. You're drawing the top and the bottom. So the top should just be 108, 98, 98, 123. That should repeat 10 times. Those 4 strings should repeat 10 times. Then you do the one for the bottom 10 times. Yeah. So that's the bottom brick there.
Repeat that second.
Well, you got 2 of them there. So.
20. 1, 2, 4, 5, 6, 7. Let's just do 10 rows. Well, 10 ain't got a bit either. 10, 11, 12 rows up there.
You've got 4 bricks in there right now. 4 brick tops.
Okay. I'm trying to do them like so we can see like these would be the first ones, these would be the second ones, and go down with all of them.
Oh, if you want to do that, then just make it 4 characters. 4.
I got to do. So let's see, we got 1. It's 3 of 3. Is it 3 or 3 or 4? 4, right?
Well, that's 1 brick there. That's 2 bricks. 3. Okay, yeah, you got 3. So 2 lines. You got 6 so far. You need 4 more. Or you're going to do 4.
4 and 4.
Then you need 2 more.
Mm-hmm.
Or you can just add 1 more to the end of each row there.
Okay. Did I get it?
Take off 2 bricks from the end.
Got too many. 2?
Yep, that's 1. There's 2. So that should be 1 row of tops. Yep, and then basically you do the same thing.
I have to repeat it over and over again. Do the same thing with this. Same 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Why is that shorter?
Shorter because of 98.
Huh?
So you need 1 more brick there.
On the end?
Yeah, then that'll give you 4 bricks on the byte line.
So 124 here?
Just hit paste again.
Oh, so I don't need that on the end, you're saying? No, I was just trying to verify I had the right number in the rows. So I need to paste this whole thing. Always move over here.
Yeah, you were missing. So on line 34, you're 4 bricks across. On line 40, you're 3 bricks across.
I am missing one. So just tell me what I have to type in here. Does this one have too many? There should be 2 of these, right? What were the numbers again? So 124, 226, 226, 126. 24, 226, 226. Oh, I see. So it should only be 226 and then 126. Oh, it's right there. 1, 2, 4. I'm going to go wrong. Write that in reverse.
The brick itself is correct. It's just you're just not consistent on the number that you have represented there.
So the numbers are good.
All right, stay here just for a second. Let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You have 11 bricks defined in what you have there for the bottom. So if you just want to fix it, you can just take off the last brick.
I need to take off the last one, this one?
Yep. But what I was saying is that up above, you've got 4 bricks per line, and then you've got bricks on the bottom line, whereas in the next one, you've got 3 bricks per line.
Okay.
You've got 1 brick on the bottom line, so I don't think it matters.
Cents. Right. And what we're going to do is draw the top brick, and then we have to calculate that, and we'll draw the bottom brick somehow.
Well, so I think we can draw the top brick and the bottom brick in one shot, and then we need to know after that, because we can change the color of the brick.
Well, actually, we can't for a reason, because when we go to draw this next to this, it's going to draw it right next to the other one.
Yeah, but it'll wrap around to the other side of the screen.
Do you think it'll work? Okay, I see what you're saying.
You don't think that'll work? I was thinking that it would just wrap around to the other side of the screen. You really don't need to.
We don't even need this. We can just leave it top brick, and it'll go right into the next data anyway.
Yeah.
Let's see what happens. Okay, it's more. Something's not right. It's not interfering with that data again. So these are not correct with this. These are good. These are all screwed up for some reason.
Oh.
You know what it is? Is it some of the data wrong or something?
I don't know.
Because why is it drawn 2 new ones here but not any more here? So maybe we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. We got too many, I think. 8, 9, 10, 11, 12. We got way too many on
Oh
there.
yeah, you got an extra row there. Hang on.
So we need to take out the row.
Take out row 36. You can just delete row 36.
The whole row?
Yeah.
We
Because you got 4, 4, and 2, which would be 10.
Do we need to take this one out too?
Hang on. No, hang on. 1, 2, 3, 4. The bottom brick is fine, but that actually, did that ever even get called?
Is it what?
Did bottom brick even get read? Did it ever draw bottom bricks? Go back to the.
It's just going to read right when it's here, read into the next lines. It's just going through memory to read the next data.
Okay.
I just did this to make it easier so we can understand it. I should be need to change it later.
Yeah, try running it again.
Okay. All right. That row looks good. The bottom row's off.
Well, we were only supposed to print one row.
Oh, okay, okay. That's because it's repeating. Okay, so we got that. We got it working then. Good point.
Yeah.
That's why this is doing this.
Yeah, I don't know why it keeps going after that, right?
That's because of the loop we have going on.
Yeah, yeah.
I think what we're going to work on. I'm just going to see something here. Why it's doing this.
Oh, yeah, it missed the last corner there, it looked like, huh?
Not getting that. Missing that last light.
Are we off on our data? Oh, yeah, we're one short on our data on the last row there.
Oh, right here.
On line 42. On line 42.
Oh, okay, okay.
Comma 126.
Oh, so we're missing one.
Yeah, that's that corner.
Okay, yeah, that's right. That's right. Okay. Good eye. There we are.
Yeah.
Ooh.
So now after you print one row in one color, you then need to, you want to change it to the next color.
Yeah, that's easy to do that. But the hard part is going to be, can we get this all in a row? So far, we don't have it doing that.
Well, I think you can just keep going again. You
mean just keep adding more data here?
No, you don't need. Well, I guess you could add more data, but what you got there.
Did we just copy this again?
Well, you could do that, but can't you just run this again rather than copy and paste it? Loop that again to write the row.
Yeah.
You could do it like this too. I mean,
put it all on the screen. If we could do that, it would probably just be more easier to do that. But it's still, I don't know why it's doing this. Probably because of that 256 byte. We're going to have to fix that somewhere. I don't know. Let me just see something here. What we need. Uh-oh. See if that works. I just wanted to get it looking right, and we'll go back to what you were saying earlier. So it's like getting weird right here.
mm-hmm.
Which is why I really wanted to do it the other way. Because when it gets to 255, it's going to start back over again. And that's what's throwing it off down here. So this is the 255th line down here. Let me see something here. Increment 252. Let's see why it would have done that. The data's all correct, right? It looks fine on the top and bottom, so it should be good.
Can you paste bin that to me? Then I can look at it a little closer.
Sure. There's a reason why we're going to have to do that eventually, though.
Okay.
When you go to move the sprite up, and it hits the data, we have to know where it's hitting at too.
Yep.
That's when that math algorithm.
Yeah, and you'll want. So we're just drawing all the bricks at once now. Whenever you erase the brick, you just want to erase one brick at a time, right?
I just did this so I could kind of see what it looks like and see if there's anything wrong. Or we can go back and we're going to have to eventually just do the top and the bottom brick. Because we only want to focus on those 2 rows and, like you said, repeat them. I'm trying to see how we're going to do this. We have to set, like we were doing, we have to set a starting place where we're going to start our calculations at. And then we're going to just start using the 40, this one right here, the 40. And once we're done with this, we're going to load whatever's in here, and we're going to pass it into, well, it's getting a little complicated, but we're going to have to pass it into that screen memory to calculate it correctly, like the basic program did, or similar to the basic program. So I always have to write this out because I can't think looking at the screen. So we're going to need a 40. I'm trying to see how many variables we're going to need. You'd want to keep track of the multiplier for 40. I think we're going to need that. Where'd it go? Right here. This one. Let's see, equals just like I did there, we're going to set a separate subroutine so we don't just, mess it up in the code somewhere. So we can refer back to it once we get it working. But first we have to load all these. Because right now, it doesn't know what's in Y32 low yet. You haven't done anything with it yet. I'm ready to shut this one down as many times it keeps opening up. So here I set an X1 and I set a Y1. That's how I stored it. Y40, Y40 high. Oh, I used 253, that's what I did. Which is kind of taking, well, we could use 253, 254.
How many bytes on the 0 page at the end of the 0 page there are free?
How many are free? Not very many.
Yeah, you started the other one at what, 251 or 250?
Yeah, there's only a couple. 251, 252, 253, 254. That's it. There's a few others, but you can't use them for high bytes because they have to be next to each other.
Yep, okay.
If that makes sense.
Yep.
So anyway, so let me think.
You basically have 2 that you can do then.
Yeah. Which is good because one is used for color, one is used for character. That's how I've always done it. Anything beyond that, I just create my own. But I'm trying to see. So somewhere in here, once we go past the first row, we'll probably have to make it figure out how many it's draw on the screen first. Otherwise, it's not going to know how to jump down to a line. It's going to keep drawing. Well, you said it's already going to draw across the screen, so we don't need to do that. So when we get through the first row, we still have to count it. It's not going to know unless we tell it how many it's drawn on the screen. Otherwise, this is going to keep drawing one after the other, and that's not what we want to do right now.
Yeah, we basically want to count to 80 and then restart and then draw them again.
Oh, so you want to do rows of 80 then?
Well, you do the top, which is 40, and the bottom is another 40, so that's 80 total. and that would be the next row of bricks where you would
Okay.
color.
Okay, let me write that down. So we'll draw top bottom. And then after we got the top bottom, that's when we're going to use that math routine.
Yeah.
Do you have any ideas for this? Any thoughts?
No, I have no idea how this math works.
As I try to figure this out, like, I have to see it visually, I think. So if I draw them on paper, I might be able to see what I need to do. We'll draw the top and the bottom, and then we're going to multiply it by 40. So somewhere in here, we need to calculate a starting position that's going to keep track of the 40 variable, which should be this one right here. So I guess we could just use Y low. The high and the low byte, this is the fun part. You got to keep track of not only the low byte, but the high byte. This is the part that's probably going to blow your mind. This will blow my mind.
Well, yeah, so because you'll overrun
Right.
the high byte too, right? And that's where you got to basically reset everything.
You have to figure out the overflow. Just like if you're doing in math, if you're adding numbers, you have to do what's called a carry.
Yeah.
You have to figure out what the carry is, and you have to keep track of the carry. So the accumulator will actually keep track of it, but for you to be able to calculate it, you have to store it somewhere. It'll never store it if you don't store it. It only accumulates. That's the part I'm trying to figure out right now, like how we're going to do this, because this is the algorithm for the 40, and it works, but we need to get this translated to the screen somehow. Because this one is for the times 8, this is the times 40. So I'm not sure if this one is eating off of this one, or if this is feeding off of this one. I think these were just separate multiplication routines I had. That's why I put them separate like that. 8 equals 80, 11 times 8. So this is saying in Y character, it started at 11. I think I'm starting to understand this now. I put 11 in here for some reason. I started at 5 right here. Oh, I subtracted 5 from it. I think I know what it was. This was the result. The result was 11. So I think you were right earlier. So this is the result. And then after I get the result, I'm multiplying to make it go down the screen, or until I get to 32. Now the problem is when you get to 32, you can't calculate to 40 because it's only going to increment by 2 each time. And what is 32 times 2? I think that's
64.
Yeah, so it's higher than 40. You see what I'm saying?
Yeah, you need
that's where the carry bit comes in.
Right?
Yeah, it's complicated. So the way it works is, this is the part I had to figure out. You're gonna somebody was trying to explain. You're gonna calculate the 32, because if you try to do 32 times 2, you're already over the 40, and that's too many lines down. We don't want to go down 64 lines. We only want to go down 40. So we subtract 40 from that, 24. Somehow I got 22 as the difference here, but I think in my program I put 24 somewhere. Right there, there's 24. So 24 is the leftover. Does that make sense? It's a leftover amount minus the 64.
Okay.
Which is basically our high bits. That's why they're keeping track of those. This is why it's a little complicated, because first you have to calculate it. That's why I did all this. Now I'm starting to remember. So we can probably rule this out because we're not ready to capture the character, but we do need this because we need to know. We first have to multiply. He explained it. You first have to calculate by 32, and then you have to do the 8, and then you add them together. That's why he did this. I'm starting to remember now. I think I just have to copy all this. Right there, right? That's all I need. Program go again. Change all this. Let's Now here's where we get to have fun. To make sure this is correct, each time what I've been doing is doing this. break-in. You asked me earlier how the monitor works, and we're going to have to look at that next because we have to figure out what's in these locations each time to make sure it's calculated. Now I know it works, but I'll show it to you anyway. So Y32 high, and we also have to do it at Y32 low, so we probably have to break down here somewhere. We break down here, it's not going to be right. Y32 high, Y character. So this is why you saw this on the screen, because I was calculating it and I was keeping track of what was going on each time. So I knew when I added it up, the results were correct. Because I couldn't figure out any other way to do it. Did that make sense?
Yeah. Tired.
What's that?
That I'm tired.
Yeah. I have to turn it here very shortly too. Right when it starts getting interesting. So Y character, I started this to keep track of where the Y character is on the screen. So this is basically telling us where the character is going to be from a Y perspective. Because what we're doing is we're just calculating it from screen memory. So like how many characters down the screen would that be if we ran the program? Oops, I ran the wrong one. If we ran this, what now? I don't know why it's doing that.
It says you're missing a label.
Oh, I didn't define Y character. That was my fault. So here I needed to define whatever Y character was. Where is it? We defined it down here somewhere. There it is. X and Y character. That's what I did. I have a bad having defined mine at the bottom of the screen, but anyway. Okay. Here, we got the Y character. Run. What happened? I know what it is. When it gets here, it acts as a break. So this is why I've always done this. I've seen this in a lot of routines. I always stick my bytes at the bottom like that. It seems to break the program otherwise. I have no idea why it does that, but it does. So what I'm trying to figure out is how far down our Y is going to start. So we just can count it from here. 1, 2, 3, 4. We get set it to 4. Actually, we want to start at 0. Right? 0, 1, 2, 3. So we'll set that to 3. Where's that? So we're going to start calculating at 3. And then we're going to multiply the screen position. So all this is doing is this. Let me just explain it this way. Everything's getting stuck on the screen now. So Y character is keeping track of the vertical position. We're just called placeholder 1. And then also need to multiply. So we're going to need another one. This is what the Y40 thing is doing down here. Here's this one. Kind of low light, of course. This is going to be our times 40. Like we had in your example, so we know this is going to be added when we're done. We're going to add Y character. I was going to just add 1000. Let's say our line started 1084 plus Y character plus Y40 low. And of course, it'll figure out the high once we do this calculation down here. And then the result will be in 254. So this will be the top part low, and this is the low part, or the high part high. So essentially, it'll look like this. Does that make more sense? got the white character. This will be, I forgot to add the high on this one, but this is the white 40 high. These two characters are going to make up that 40. So as we're calculating down the screen, it's going to figure out. That's the best I can explain it. now let's get it working. So what I wanted to show you earlier, if you have a moment, is how to use the monitor. So we'll just start, for example, we already got a white character. We could just start here, for example. Actually, no, that's a bad example. Because white character isn't in any memory location. We could just do it right here, I guess. What I like to do is something like this. Right here, and then we'll see what is the result of this. And this is multiplied by 2 will be stored in this memory location. So it'll break when it gets to this line, but the problem is that we haven't ghost up to this routine, so we need to do a ghost up here. Ghost up is just basically a JSR. So it's probably going to do something wacky, but I'm going to stick it in here anyway, which is what we're trying to accomplish. So we need to get through the first line. This is going to go actually through 255 characters, which is not what we want to do. So we need to check this to stop. How are we going to do this? What this is doing is it's drawing up to 255 each time. But we don't want to draw up to 255. We want to make it stop once it draws the first 2 lines, which is what, 80 characters?
Yeah. So can you do a compare to 80?
Compare Y or something? Yeah. Probably going to do something really weird, but we could probably compare Y 80 or something like that. The problem is we don't want this affected either, because we still want it to branch based on whatever this is. We don't want this interrupted either. Well, actually, we do, no, because we're changing that.
Yeah.
Y 80, 80. And then let's see if that just draws the top.
Yeah, let's see if that just draws one row, right, top and bottom.
Really weird. But it did draw the first top line. It just went because it went down into the next. If we put a RTS right here, it would have stopped right there anyway. So I'll show you. There you go. We just draw the first line. So that part's working good. So we're just going to leave the RTS in for now. So once we get the first line drawn, this is where that math routine is going to come into play. And we're going to break down here so we can look at 253 and see what the value is in memory location 253. So now you get to see the monitor. I'm like, what happened? So what's going on right now is the computer ran the code and it went to the monitor. So it's basically the same thing as exiting back to basic. And now we can look at the values that are in whatever 253 is. I don't know the hex for it. FB. We're going to look for FB. You can also notice something interesting here. If you go, is it this one? Right here. You can see the X and the Y registers here. And you can see things being passed into the registers here. I won't go into all this explanation, but this is the accumulator. This is showing where in memory it's starting, where it's basically at right now.
The program counter, okay.
I don't know why it's at B5, and that's kind of weird. B5CF. Like that. Kind of depressed or something.
Well, that should be where you broke, right? That should be the address of where you hit your break.
Yeah, but we're not at 58,831. Our program doesn't start at 58,031. Oh, it actually does. Actually, you're right, because it started at 49. I forgot we were at 49,152. My fault. So actually, yeah, that would be right. You're right, 50. So that's where we broke at. Okay. Then it's working. Good. Thanks for bringing that to my attention. Okay.
That's
now.
neat. I couldn't quite see which icon you clicked on there in the monitor. It was.
Yeah, I can't. One thing I can't do is I can't enlarge this.
Yeah.
Oh, zoom on this.
But it's one of those icons up at the top on the top row on the right there that looks like a window.
Which one I clicked on? This one.
Okay.
Okay. Well, at least you could see it. Everybody else is not.
So then you were gonna also try to look at a particular address. What I've been doing is I've been going to view and then memory and then just scroll into that address.
Yeah, that takes a lot of time. Look at that. You're right. That's what we're going to do next.
It does remember where you were at, though. You know what I mean? If you come back into the monitor, as long as you leave it up, it'll remember where you were at.
Yep, I did notice that. So did you see when I put Y in, it brought up 10. I don't know why it brought up 10 because we didn't have 10. We had 21, wasn't it? Or 8. No, we had 80. So I don't know why it's bringing up a weird Y value. That's kind of weird.
How did you look that up?
How did I look up the Y right here? It's in the registers.
Oh.
Yeah, it's very small.
Yeah, 0A, okay.
Yeah. So the hex is for 10. But, oh, I know why, because we still kept going. We never, we went down here. We didn't change the Y. We broke out, so it should stop right here. Why in the world would it change Y? Compare Y to it gets to 80, branch back to DS. It's not jumping out of here anywhere. It doesn't get here until we're done with all that. That's really weird. Well, I've seen it do weirder things, but notice the X register is still 0, though. Even though we loaded it with 2. But, anyways, did you notice this 01 shows 37 in it? That's the carry. I think that's, what's that called? Can't think of the name of it now. So let's see what it's 32. It's 50. Is that right? 50? Did I do that right? No, these are hex. 37 is at 55. So anyway, let's go back to what you were saying so we can see if it's working. Okay, I'm shutting this one down. I don't have too many times.
Is there a way to monitor up to it while it's running, or does it have to freeze?
No, you have to freeze it every time. Look at this, I got 2 of these on here. I didn't notice that. You can do more than one.
Are they different?
Yeah, no, they were the same. It's like every time you click on it, it brings up another one. But what it's doing is it's getting to this break right here, and it's stopping the program. So it's not going to any of this code. It's just stopping it, and it's saying, what are my calculations at this point? That's why you brought up this earlier. Right? So we could look up what that value was. I think we were doing that last week, if I remember. And was it FD? I think. I remember what it was just a second ago. I think that was 253. Where is FD? So FD shows a 6 there. So this took whatever was in here, wide character, which remember earlier we had a 3 in it, right? And then what it's doing is it's multiplying that 3 by 2. And what is 3 times 2?
6.
So it's working. This is what I had to do every single line. I had to make sure I calculated to make sure the results were right. You know. So our goal is to get it to multiply by 32. So we want to basically stop it down here somewhere and see what the math looks like. So we remember where our Y is at 3, so it's going to be 3 times 32, which is what? That's our next goal. This is just a placeholder. We're just going to reuse this one. Should have just copied it. So if I do the math here real quick, times 32, 96. So we need to get it to 96. And make this thing larger so it fits on the screen. Scroll it so much because you can't roll your mouse through it. Maybe like page up and down. Maybe you page down too far, it doesn't. Okay, there it is. It's 96, so it's working. Does that make sense? It took the character. Remember, it started at 3. I'm gonna have to change this to show you. This started at 3, and then we're just calculating this each time. This 11 is going to be a 3, by the way, by 3. Actually, wait, I did something wrong here. Actually, let me do this. 3 times 2. So we don't have to go back and check every single one of these lines. I wanted to show you what's going on. 3 times 4. 3 times 8. 8 times 16. I don't know what that is. 48. And finally, 3 times 32 is 96. So that means our 32 routine should be working good. So we should be good. Did that make more sense when I did it that way?
Yeah.
So it's saving everything here each time. And that's this value right here. It's changing. That's what it's doing, is it's keeping track of what's rotating left in the accumulator, or basically figuring out what the high byte is, keeping track of it. So once it gets past 40, this rotate will do the math for us. It'll figure out what the 16-bit value is by flipping it back to a 1 and adding it. And then later you just add it to the low byte to get the high byte. It's a little tricky, but that's how the 32 works. So the 32 should be good from what I've seen.
So why do you call that multiply by 40 when it's really multiplying by 32?
Oh, no, this is 32.
Right, but your label there on line 45 is mult 40.
Oh, I called this 40 because the whole thing is we're going to calculate it by 40.
Right. But
42
this particular routine is doing the 32.
Yeah, but we're going to use both of these together. So the whole thing, I just came up with a name.
There's no new label there for the next part where you do the 8 to get it to 40. I got you. Okay.
That's why you have to add them together. Okay. So we need to come down here again, and we're reusing Y character again, so we're going to redo our calculations again, except this time for. All this is just keeping track of the bits. We really don't need this. We could just use this part at the back so I could understand it myself the first time I was doing it. I need to find the T. So 3 times 2. So we're kind of repeating again here. 3 times 4.
Sure.
We're going to add. We're going to wait. Yeah, there's something wrong here. 3 times 2, 4, 8. Yeah, that's right. 3 times 2, 4, 8. 24.
So is this why BASIC runs so slow compared to machine language? Because I can just times by 32 and not have to go through all of this?
You're exactly on it. Yep. There's a lot of calculations constantly going, especially the floating points. Those are complicated, and they really slow it down. That's why I got this really cool book. I'd like to kind of do a review on it one time. It shows how to speed up BASIC. It's like the coolest book I ever read. It's like, it says take like your arrays and you stick them after the variables and stuff like that. You have to, I'll see if I can find it online and give you a link to it. It's a really cool book. So anyways, back to this. So 3 times 2, 3 times 4. We only need the top 3 basically, because we're only going to multiply by 8.
You're going to get to 8, yep.
And then add it to the 32. So I think I did this right. 3 times 2 is 6. 3 times 4 is 12. And 3 times 8 is 24. which should be,
That's your times 8.
yeah. I'm not sure why they did this twice. Anyway, let's go back and check the results as we run this one. We could also say 1, 253.
That's you're doing your rotate with the bit, right?
Oh, from one of the other values.
So you can have the high-low.
I'm going to keep track of 253 and 254, see if we get the same results, and we add them together and we get the 96 we're after. I wish this like opened up everything at once. You always have to go through here, click on this every single time. Now, if we change these, if you click on these, you'll notice these have changed too. So there's calculations going on now. So some of these numbers have actually changed. We know this one's probably changed.
Yeah, that's kind of behind the UI and now it's not quite.
Oh, you couldn't see it?
Like, yeah, there we go. That's better. Well,
what I did is I clicked on this earlier. I didn't realize I was behind.
I need to figure out how to hide my UI. Hang out here.
So this one stayed the same because we never changed the Y register, but some of these other ones have actually changed because we're now using the 0. The 1 is probably the same, but we're using the 0. What's 2F? It's 47. But you'll see those changing when you're using the math. Anyway,
so the 0 and the 1, those are the carries for the X and the Y?
I believe so, because this is supposed to represent the 0, or whenever a value falls below 0. And this is supposed to be the carry. So this one may not have changed. This one may have changed.
What's the S?
Stack pointer. That's a little bit more if you want to save values on the stack, which we haven't. It does things and it's saving things on the stack, but we haven't done anything with it. But you can save stuff on the stack if you, which you asked me earlier how they do it in a register. You can push stuff onto the stack and do it that way too. That's just another lesson itself. But getting back to this anyways, if I lose my train of thought here. So I wanted to see what the 37 was. It's 55. I don't know if that's coming off of a calculation or where that's coming from. But let's go back to the monitor anyway and see what our results. I remember I saved 253 and 254 to see if they're calculating right. Fortunate for me, the routine, I had fixed it from before, so we should be good. Where's my FD? What's already on the screen? Down at the bottom. Way at the bottom. It goes like right off the screen as soon as I scroll. It's right here. So the 90, see it? 96?
96.
Perfect. And the other one? 24. So it worked. Did that make sense? See? Our result was 24 here, and the result was 96 there. Is that starting to click for you like that?
Yeah, you're gonna have to give me this so I can go through it again.
Okay. Because remember, this is just, the 3 is keeping track what's in our Y character. It's our vertical position. So really it's saying vertical times the number of calculations. This is 2, this is 4, this is 8, and so on. Remember, they always multiply by 2. That's why I got the 2 in there. And the 2 is calculating by 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. Same thing down here too. That's why I did all this earlier. So people could see 2 times 2 is 2, 4 times 2 is 8, 8 times 2 is 16, and so on. So now we got our 40. Well, all we're doing down here is we're adding them back together. So we got the calculations and we can now move it down the screen. But now, how to get it to work. Well, lucky for me, I've got this program, so if I can just remember how I did it here, the one I did earlier, that is. I had it working, sort of. Then I think I left it on the screen. Is this it? I think this is it. Of course, I was going to forget what I called it again. It's an easy section to find though, because it's a lot of cognitive code right here at the bottom. Calculated by 255, because mine is calculating 255 characters.
Yeah, you're doing the whole
Screen.
whole screen, yeah.
But I don't have it finding it. All right, maybe that's not the one I used. What happened now? Boy. So many versions of this, that's the problem. Maybe this wasn't the right version. Oh, yeah. There. So what did I call this one? C64 scrolling four-way. Suppose this one. It's probably a final watch. Is there a final here? That one I had was this one. There's nothing there. Let's see what this one says. Probably something different. Towards the bottom. Needed to start dating these. So 10, 11, 2015. I guess that's why I didn't date them. Final, spaced out final.
They're all the same date too. I guess you must have copied them over from something else. Huh?
Yeah, I did. When you click on them, you'll get the actual dates. 7/17. This is an old one. 1/14. That's old. So the one I had earlier was 4/2016. So I did it in. Wait. What? That was a couple of days ago. Oh, it's because I saved. That was 4/9. That's because I saved it earlier.
Yeah, earlier today.
That's not going to help me now. I could probably do this. I'll make this easier on myself. Just go over here and see what we did there. Actual photos. Put these over. So I'm looking like for the most recent file I would have saved before today's date, of course. Are these dates are not in order. Why are they not in order? They do some kind of weird numbering when you have yours like that sort. Like here's January, December.
Huh.
That's the most recent version. I don't think I worked on it this year. I started working on it last year, unless it was in January. Oh, so it was in January. Because these are all saved in 17. Unless I'm just in the wrong crazy folder. Nothing to know. I'll go back to folder here. Oh shoot, I'm going to go back to folder right around there. I copied it. This is all the counter stuff I ever created. These are in January 2016. None of these have anything to do with the game. 20. 2015. It's got to be one of the other ones. Let me see our project in there. Oh, you know what? Because this is C64 Studio, I bet. I started with C64 Studio and then eventually moved on to CBM.
CBM was the first one I've tried, the first cross assembler I've tried.
Oh, nice. That's a good way to start. I have a feeling it's a stupid final one. Why should be the final one?
I don't even know how I found CBM.
How you found what?
Oh, I don't know why I picked CBM to start with. I think it was just the first one I found.
Just out of choice, or
I tried to order a freezer cart with a monitor. I think it was the final cartridge or something like that. And so I bid for it. I won it off eBay, shipped from like Italy or someplace like that. Showed up with the envelope torn open and had the documentation.
I didn't quite get everything you said. I heard something about eBay and.
Oh, I tried to get a monitor cart, final cartridge. Because I initially thought that I crazy enough that I would try to do this on the C64 itself, but that is just too difficult.
It is, and you know what? I actually own that.
Oh, the final cartridge.
Yeah, it's probably worth a fortune, but for some reason mine doesn't work very well all the time. It may not be worth as much as I thought, but I had to do a video sometime on it. But yeah, I've actually got that cartridge from the very first time I bought it. It was like $60 way back in, when they first came out with it. I'm so tired of making this too complicated on myself. All I have to do is look for those symbols that we created because they're always at the top of the page. I'm just getting too tired. Let me just see what this is. I don't know if I looked at this one, so it should be right here because I created them and I stuck them here at the top. But if they're not in here, then it's not the right one. I think we're going to waste too much time on this. I just want to go back to this and just start working it out again, I guess. Well, I had the code there somewhere else. I have to pull that back out. So we know we got the calculations going on. Got a little sidetrack there, of course. Next thing we need to do is we need to pass them into the memory location here, because this is where it's storing that 1184. And we have to add them to this memory location, essentially.
Yeah, that'll move it down.
Yeah. That's going to be tricky.
The calculated address.
To do that, we would have to load the low and the high byte, and then we'd have to store it in the 251. What we're basically going to be doing. But this is only going to store the low byte, so.
Well, and you need to add them together too, right?
Well, we probably missed that earlier, but this is what this did down here at the bottom. There we added them together. I skipped that part, but it's got the 253 there and 254, so it's done all that calculations for us.
I meant you need to add 251 to so 251 and 252 are our starting address. You need to add 253 and 254 to those.
We have to pull this data in somehow.
And then store it back into that address that comes out of that calculation.
Why we have this. So what we could probably do is test it again. See what value is in there. Because if it didn't calculate right, we can always check it right here. Because this time it's going to change whatever's in 253, and we break, it's going to let us look in 253 at this point because we stored it down here. And then what we did is, oh wait, did we remove the break already? I think we did. Oh, we forgot to remove this one. We break that, go down, and we calculate the 40. You can ignore this part. But this is essentially what we're going to do is we're going to be adding it to the screen. So it should work. At least we should have either a 24 or 96 in there. If we don't have anything else in there, then we're in trouble. I love how it keeps defaulting everything in the same spot. I'll be off the screen again. It's in the center. It's 216. That's weird. Wait. That wasn't our number, was it? We used 253. Yeah, it's 216. See, this is why it's important to check, see what's going on with it. For some reason, we got up to 216 now. This is how we got to 216. Somewhere around here, we went awry. Probably this. This is supposed to keep track of the 40. Did we change 253 anywhere? We don't use 253 here anywhere. But we forgot to clear up 253, I do know that. Because 253 can have anything in it. If we go here, oh, we can't do that while it's open. I'm going to try to look at the value, but it won't let you go in here while this is open.
Yeah, and I really wish there was a way to live monitor.
There probably is, I just don't know how to do it. Anyway, to go back here, it should show that number, 216. What I always do is clear it out. Clear them both out. Just to make sure there's nothing else in there.
Uh-huh.
You never know, they could be used by the computer. Remember, they're open registers. So we can still go here and we can still peek them without having to go to the monitor, which is doing the same thing. And it's still in there. So something changed there. Because we stopped it here. I know we broke it here earlier and we broke it here earlier, right? And we checked them both earlier and they were 24 and 96, right? When we got here?
Yep.
Where else did they go around? The only other place right here is this Y low 40. We need to see what's in there, probably. We're adding 253. Oh, we're adding it here. So we're taking what's in 40 and adding it to 253. I bet that something's screwing it up right there. Let's see what it looks like here. Now what this is going to do is it's going to break here before it gets to here. Because it's already JSR earlier here, so we don't even need to change this one. It's still going to keep track of the most recent one that we JSR to, or jump to subroutine 2. So we can still go back and run it again and peek it again. Let's see what it looks like. There it is, 96. So why did you steal it from us?
So yeah, what's the plus, the times 40 plus screen doing?
What's the number?
It was 216.
Are you wondering how I got to 96?
No. What's the purpose of this part of the code?
It's to calculate the 2 bytes together, the 32 plus the 8. I put 40 here. I should have just said 32 plus 8, and then you add it to the screen. Y character. So we can get the correct calculation. For some reason, it's put 216 right here. So whatever this value is messing up this. But I'm pretty sure we didn't do anything to Y40 earlier. That's something down here went wrong with it, which is probably why my program never worked right. What we got? We got 32, 840, 32, 840. Well, this is where it gets tricky. So we're basically taking the 32 low, because we want to know what the low value is in there. And we're adding it to the 8, because this is just doing that 32 plus 8. Get the result 40. That's what those two are doing right there. Separate that.
And then you store it.
Stores it in 40, so this is the result. 32 plus 80 equals 40. I should have take this out. And that's where it stores the result there. Make sense?
Uh-huh.
And then, what is this? Too high. I'm trying to figure out why they did the high here. We don't really need the high because we're never using the high value. That's probably why it's not working. Because I used it in my program, but we might not even need it. Let's see what happens now. We're also clearing out the anything about that either. I'm throwing it out. $96, there it is. Okay, we're looking good. So something in this high value was adding the high bits in to this to bring it to 216. So whatever 216 minus 96 is where it was getting that. It was adding 120 in here or something. But that was to do with the other code that we had. So now we know we got the results correctly here. And when we go back to here, we should have our 96, right? Which is what we need to calculate the 32. And then we take the 32. Remember, this is just a low byte of the 32. We still need to add it to the 253, but that's what this goes down here. What you eventually do is go down here, and you store it in one giant variable at the end, like result or whatever. And I would take both of these and store it in there. Okay, so that's right. 40 high, 40. I probably did this wrong. Load the 40 high. Have it here 253. So. No, that's right, because it's basically doing one after the other. It's supposed to store it in. It's in 254. Let's see. If it's 24. Okay. They're both there. I don't know if I ran this and I'm going to rerun it again anyway.
You put a label in for result.
Oh, I got an error message. Oh, the new variable. I forgot.
Don't you want 2 bytes for the result?
We already have those. And 253, 254. Oh, that 216 came back. Essentially, we would have the 24, which is the 32, and the 96, which is the 40. But this 216 snuck back in. Why did that sneak back in? Every time I come back here is where it wants to go haywire. So what did I do the last break? I did it right here, right? We're probably going to have to break one of these again and see what's going on with this one now. The value is messed up now. It's 253. It's changed here. What the heck? It doesn't make sense. Put 96 there. Quick results when we break here. So it shouldn't change 253. For some reason, when we store it here, I bet this is, it doesn't really make sense. Loading pivot to Y40 high, advert period 40, store 254, and it's never changing 253 anywhere else in the whole program that I see.
What's that clear carry doing?
That's just used for the math. You want to clear the carry, otherwise you're going to have funny results in it.
Okay.
It's just required when you're doing math. I'm almost curious to see what happens if I break down here now. Or I'm not here. Here, I don't think I broke here yet, did I? I get a point eventually just breaking on every single line just to see what's going on with this crazy accumulator. Notice I'm not using the monitor anymore because all we have to do is peek into those values now. I just wanted to show you how it works in the monitor. This is a lot faster. They're going to be the same results. So if we go to here and look at it again, it'll be the same results.
Sure. Yeah.
I'm sorry you believe me. I just wanted to show those who are probably watching too. They're probably confused already. Try to keep them on page 2.
I like your method.
Yep, that's right. So 216 and 24. Exactly what we have. So we're good. Let's say our 216 is getting thrown off. It threw up here somewhere. In this. Did we ever use Y40 high? Wait. We used Y32 low. Oh, remember we never used Y40 high, did we? We took it out.
You commented it out.
Yeah, because we didn't need it. Not yet, we don't. But we will. And can you guess why? Here's why. So when we get to 40, and we're multiplying it by each time, because we're going down the screen each time. So 40 times, 40 times 2 times 2 times 2. Oop, now we're up in the high byte. So eventually we're going to need to keep track of the high byte. But I just wanted this to work a few lines down so we can get at least the first calculations working in. Then we're going to need to turn these puppies back on, which is why I commented them out. So this is basically keeping track of what's in the overflow each time. If we comment this out, it'll go back to what it was. We should now have the 24 and the 96. And this is worse than calculus. Can you imagine doing this by hand back in the days? That's what people did. 216. Why in the world did I? Oh, I forgot to take. I commented out the Y40 high. What did I do wrong? I just assumed we was here earlier and it said 96, didn't it? When we broke here earlier?
Yeah.
I'm pretty sure it was 96. Why is it 216? Why is it 120 bytes higher? Okay, now there we go. There's our proof. It's 9624 at this line. But as soon as I go down here, it throws up. I don't think I broke it right here. I'm going to go right here. Anyway. You see why I had to do this line by line by line now?
Yep.
It's complicated. The other guy that was showing me, he could do it all in his head. Show up. I got to run it. He's like, can't you do it in your head? I'm like, no, I don't do stuff like that in my head. I need to see what's going on. It does not like this. Why? It's because we're adding whatever's in here is getting added into there. So somewhere, I thought we put a 0 in there. Well, why would it throw anything else in there? We don't have anything else in there, do we? Oh. This was my fault. We did. Remember, we did this. We had these separate earlier. I stored this, and I stored this. So this was my fault. I was doing this to keep track of the values. So it was basically taking the result of 96. I think I can figure this out now. 120 minus 96 is 24. So I was adding an extra 24, 120. So did you see how I did that? Basically, this 32 times 3 times 32 is 96. So that would be the result that's in 253. So if we go down here, put this 96, then you go up here. What was it, 40 again? 24 was it? 224, 96, 120.
Yeah.
120, and then it was adding that to the other 96. So you make 120 times 2, or not times 2. Anyways, I see what I did wrong. It's because I was trying to re-add it, I can't, basically. Which is why you don't want to use the numbers. This is what he's trying to tell me. Don't use 253. Create your own values. This is why my math never worked the first time. So if we set this to something like he was doing here, like the lows and the highs and all that, we never would have had that problem. But at least we saw what it was. So we don't really need this anymore. This was just what I added. And this, now we should get the correct result. Well, actually, I can go down here now. Oh. Well, at least it changed. Something, now my 254 went away. The most important thing to keep track of is this and this. That's what I should have done. So I need to make a note here. Y32 low. We need to keep track of that. That's 32. And the Y8 low is the 8. Those are the two that we have to add together. Y32 low and 8, and it stores it in Y40 low, which makes sense. So Y40 low should be the result of the calculation that we need. So the result should be in here. I think I'm reading this right now. Let's see, what did I just do? I added this back in.
I think we wanted to get added together, though. Is that what we wanted?
Okay. What did you say?
I think that was right. We wanted it to be 120, right? Because that's 96 plus 24.
You're right. That's.
Well, I think that was correct.
When we did the calculations here earlier, so 96 was the one we needed. The other one has to be 24.
Uh-huh.
But it was 0.
No, it was 120. So it added them together.
So something got added together.
Yeah, it added 96 to 24 to get to 120.
Anyways, I need to do this Y40 high to get the other value. I didn't want to have to do it that way, but I wouldn't have to. How if I ran it? You see, it actually showed it for a second there. Oh, zeros. Okay. Oh, my fault. I used these earlier to keep track of the values. Now I remember what I did with these. So let's calculate it before we play with the 253, and we should have the correct result, which is exactly where this break is at. At least it should give one result correct. Neither 253. 96. Ah, we got him back. That's so good. So all we have to do now is we're adding, and this is what this is doing down here. It's loading the high byte and the low byte. Let's see what Bray store these in there because we're going to lose these again. So we know the 253 is keeping track of what's in here. So that's why I did this earlier. Let's make sure that it's still the correct value for 253, which is 96. Okay, I'm satisfied with that one. So we can leave that alone. Now come down here. Hope we don't lose our 254. See what it looks like. Oh, pretty sure, and they look good. Yeah. So we got away with all this. Now to be safe, we need to go through line by line. So it doesn't hiccup. So sorry, the typing is. You good? We haven't changed the values yet. We're good. What do you think? Looks good?
Yeah.
Now, when we come back out of this, please don't give me a 216. We still got a break here, so we should come back here now. We took out all the other breaks here, except for this one. If that worries me. Earlier we had this, we had this. That means it was still stopping here. Did I have that break in there earlier? It's just going to throw off our whole math if it's not right. So I better write it one more time to be sure. Imagine the guy had to build the floating calculations for this thing. Looks good. I think I'm happy. I don't see anything else break in. Now we can remove this one to continue our debugging session back to our subroutine here. And see if our 253 and 254 are still there. Fingers crossed, fingers crossed. Bingo! Well, that only took about an hour. So see, now we've got the 40 in here. We can calculate it to this to get down to the next line. So we should, let's see, JSR. So this is going to go through the 40 calculation. I wanted to only go through one iteration and stop so we can kind of look at it. Incremented X once. Oh no, we're decremented X. Get the 80, line stop, go to the routine, do the math, get the values. 42 plus 8. 40. I have a feeling it's going to hiccup down here again, but we'll see what happens when we run it, I guess. That's all we can do. Cut the break. We'll just come with it. Okay, there's still a break in here somewhere. I don't know why it did that. supposed to draw it on the screen and stop. Let me just test something here a second. Make sure it's not crashing here. And through those on the screen. That's perfect. So we know we got through this successfully without crashing. There's something that gets in here and it's blowing up now. It shouldn't. But it is. It's like it's erasing it. I'm probably doing something wrong here. Let me think here. So this is going to store what the screen data looks like. And we don't want to add it to the screen data. We want to add it to the value. So what we want to do is this. We want to say, for basic sake, plus 253. Something like that by character, which is already calculated in there. Something like that. Got the character, whatever the data is. So I was going to draw the data into the screen. I guess now we have to figure out how to calculate this address inside of here. How in the world am I going to do this?
Yeah, I think it wants to, you want it to go from 1184 to 13.
Yeah, but see, what I'm trying to do is I got to calculate it to this Y address, because this is where it's going to draw at. So we probably just need to transfer it to the Y and do it that way or something. Transfer Y to the accumulator. I think that might be it. And then that would take what's in 40 and transfer it to here. I don't know if we have to add with carry 53Y. I don't know how to do this now. Well, it's just not blowing up anymore. That's a good sign. But you didn't see anything because we never incremented down to the next row. We stopped at the first row right here. Remember? That just drew the first row. Now we need to draw the next row.
Yeah.
Which is I'm going to compare. This is where it's going to get fun. See if we can just do 2 lines down. If it's not equal, we need to redraw them. So it could lock up. Or it could succeed. See, it locked up. But it looks like it went down to the next line, doesn't it?
Yeah.
It's just drawing it very quickly on that same line, so I think we're getting somewhere. So what it's doing here is it's transferring this value, calculating it to the Y, add would carry in the Y, so it looks like it went down the right line. But it's just not, it's only staying at 2 because 2 is only 2 locations over. So we probably have to do 80 again or something. Another 80, maybe. Kick out that time, it didn't blow up. It's supposed to kick out like that, but it didn't draw the line though.
You threw something there.
It did? Are you sure?
See where the load is?
And that. Oh, actually it did. Is that part of your, what is that?
No, that's not a.
Fine.
Yeah, I don't know what that is.
Probably whatever was calculating inside of here. Because this is going to read, this is just calculating and storing it, and this does the calculation. This is just taking that 40, multiplying it by the y. So what this is essentially doing is this. Y times the value that's in 253, which we know is our 40. And in this right here, we probably have to go back and reload our screen data again. Probably why it didn't work. We want to escape past that line because we only checked on it. Did it do it right this time? Is that it?
That looks like the right character, yeah.
We're onto something. Cool. So I know what it is. Our y is not at 80. What's 80 times 2?
160.
Keeping track of y, we never changed y. That was my fault. We're just doing this a simple way, and it locked up again. Let's see, dr, 253.5. What's that?
On after between line 36 and 37, don't you need to increase y?
Right here?
Yeah.
What do you want to do?
After that statement.
Here?
But before you compare.
Right here.
Go to the beginning of line 37 and hit enter.
Right there?
Yep. Now increase y.
Oh my gosh, is it this simple? Wasn't even thinking about that. My fault is thinking it was up here because we're doing it. You're starting to get it. Yeah, exactly. That's why I need 2. Bam! It worked!
Yay.
After all that time, people, it actually worked. And to prove it worked, we can change this value. What's y 160 plus 80?
240.
We should get the next lines, right? And we don't have to redraw them. Bam! We only have one more line to go. And guess what that line's going to look like? And guess 240. But what is 255 minus 240? 15? We're going to need more than 15 characters, so now we're going to have to use our highlights. That's why we need our highlights.
Yeah.
But that's where this comes into play, 252. So we might be able to sneak and get away with this now. Not sure if I'm going to need to increment y in here twice, because if it goes back here, it's probably going to hiccup or something. What I'm going to do is I'm going to try to make it go all the way back here to the beginning, instead of just going back to here. What do you think? You know what? No, I'm not going to do that. Save it.
Can you paste bin that to me so I can grab this?
Thank you for reminding me of that, because I'd screw up. I get a point something working and I don't stop. I just keep going. You got to stop, because you're never going to remember what you did before.
Yeah, let's make a checkpoint here.
Yeah, sounds good to me. But it's great progress, huh?
That is. That's awesome.
It worked.
I am seriously falling asleep in my chair here, though, Steve.
Yeah, I got to get up early, too. I just wanted to get this space in there for you.
Yeah. Thanks a lot, man. So are you up again for next week?
Yeah, I'll be up for next week for sure. There's like 0 viewers.
Yeah. There was another guy in here earlier.
I'm going to say this is an extra piece of
he showed up in chat there.
He disappeared.
Yeah, I lost track of him, but at one point there was someone else in here.
There was?
Yeah.
I'm going to save this code example here, too. Did you follow me enough to stay awake? See what I did? How I did all that?
I'm going to have to go through all this again, you know.
I'm just glad it worked. Now I can use this in any times the 40. If I want to use it at time 40, it's going to work every time. So if I wanted to draw something going down the screen, I could draw it all the way down the screen now. If I wanted to do that one more time before we leave here to show you, we could probably draw all the way down the screen now.
Yeah, I think what was key for me was that indirect addressing. That was one of the things that I just couldn't figure out how to do. And then along with that, being able to do the math.
The math is the hard part.
Yeah. That's a lot more complicated than I thought it was going to be.
As you've seen why. So see, instead of just going to 240, what I was going to do is this. We already got our Y up here earlier. So we're going to repeat and go back to this loop instead of going to DR. I don't know what's going to happen. I'm going to try it anyway. And then we just increment the next high byte. But it probably won't work because we didn't do the 16-bit math. I'll probably do something weird or crash. It crashed. DR back to there. Yeah, it doesn't like that either. But it's been fun. I really got to go too. You got the code?
Thanks again.
Yeah, that's fun, I thought. And essentially, people, we don't need all this data now. We're not reading all this data anymore. We're actually needing what, the top two lines? This is our top two, right? We should need all the others. So we'll take all this other stuff out. I can't get this to do this. Right there, right? And we need to take this one out. Wasn't that the top two?
Right there.
That should still work. Of course, I modified the program. That's not wrong. Why did I change the data? This right here. Uh-oh. Maybe we do need it. That's the way it was. Should have just put the program back the way it was. Like, it got a little bit more. They're still not in the right place because of the 16-bit math is off. But you can still see it's drawing them down at least. I know you don't need that many on the screen, but if you change this to 255, they'll probably just cut off the other ones. See how I cut them off? That's a night. Are you there?
I'm here.
Okay. I'll let you go, and I just wanted to. So that was the last step right there.
Yeah, I'm trying to paste it in here and get it to work, and it's not.
Oh, okay. Yeah, let's make sure we get it working for you. I got 1, 2, 3. Except mine. It's going to get screwed halfway up because we're not calculating the high bit. We just need to basically go back in and throw the extra data in that we took out earlier. This should work. Open. We'll put it back the way it was. Yeah, it's still screwed up.
Yeah, I'm getting.
Oh, wait, no, that was my fault. I put the 255
here.
to the 240. And the math's still off a little bit. Breakout for now. We probably need to test these 2 or 3. Because the only thing we haven't done here is we haven't calculated the 40, and we got the 40 low. Let's see, 40 low, 40 high. What are we missing? We got 32 high, 32 low, Y8 high, Y8 low. 32 plus 8 is Y40 low. Oh, we don't have the Y40 high. So Y40 high is calculated off of this Y8 and Y32, which you probably never calculated. We calculated it here earlier. It has something to do with this down here. This is just getting the next value in each time. So we probably just need to move this routine down here or something. I'm going to do that. Once we did this, took all this JSR and all this stuff, and essentially, we're going back to DY. Oh, we're going all the way back to the beginning. Something's getting screwed when we're going all the way back here. So top row, bottom row. Definitely X register. X register is 2. If I change this to 6. It goes all the way down the screen there. You have filled the whole screen now?
Yeah. Kind of jagged though. It's like overlapping.
Yeah, something's probably wrong with the data maybe then. Maybe it's the data?
Oh, it could.
Maybe it's the data.
Yeah, it could be. I think.
Yeah, because I mean, it's otherwise it would be calculating in different positions. You know what I mean?
Yeah.
But it's calculating every row, right? It's times 40 times 40 times 40. But this is the 255th position. This would be the 250th. So it probably is that high byte. Get screwed up somewhere. Which is exactly the same problem I had in my program. I think we made a pretty good mission tonight. Did you get it working?
Yeah, I just commented out the last part after 16-bit man.
You commented out what?
I commented out lines 51, 52, 53, and 54.
Let's see how many of these damn things I need here. I don't think I need any of these down here.
Oh.
Yeah, apparently we needed that one. So what it's doing is it's always reading these down here. It's still going all the way through this every single time because that's what this line is doing. It's going right through the X register or the Y register. And it's counting each time. So see it's at 80. And then here down here it's counting 255. Let's put it back to 240. It's counting 240 of these down here. So we probably only want to make it read the first few or whatever, but I don't know. I think it's good enough for now.
Yeah, we want to do it 80 at a time because we want to flip the color. We don't really want to have it copy pasted like that. You know, we want to put it in another loop.
You want to do the color? The color is not actually complicated. You just have to set up a high and low byte for the color. And basically, we're just going to be adding it back into. So we'll basically, we won't use 253. We'll name this something else later, like Mach 40 or something. And then we'll use 253 for the color memory and 255 for the high. This is why he got me in the habit of doing all, not storing it in here. which you probably don't even need to do because we stored this. Let's see. Yeah, we never created it. I think in my original program I created results for both of these, but let's see, where did we calculate that? We calculated into 253 was the result. So whatever's in 253, actually we already did that down here, didn't we? So result will probably do the same. I think it does the same. Anyway, of course the data screwed up again. I think it's because I erased some more of those again. And something got screwed up on it. I don't get that. Result has 0 in it. Shouldn't store anything in it. It's storing what was the last value in here, which is our result 253 and 254. And there's a lot of changes. We have to go back and we have to create one for this, but I don't think we essentially need this because we stored this here in the Y32 low, and we stored this in the Y8 low, and then we just calculate them together down here. The result is now in Y40 low and in Y40 high. So essentially we can just use those two. We probably can just use that. I bet that's the answer. Same thing. Yep. That's the variable we can use is Y40 high. We don't even need 253 and 254 anymore. I don't think we need any of these actually. I think we can probably take them all out. I just did that so I could see what they look like. But we are at here in 253 here, so that might give me a hiccup. Y40 high adds 253. I wonder if it needs to Y32 low. Probably not going to work, but we'll see what happens. Hey, it still worked. Getting closer. It'll work now. CBM Prg 272 plus 1084 55 456. So I just have 160, so it's 160 and 216. 160, 216. Should do the trick. Or just pick a color, it doesn't matter, I guess. Trick is what you do with one, you have to do the other. You always want to do it before the increment. But it should turn yellow if it works. And down here we need to increment 253 or 254. You want that code?
Yeah, paste bin that to me.
I thought it wasn't. All right, I just basically pulled out the 253 out of here and used them to store the screen memory.
Yep.
And I think we can call it a night.
Yeah.
Sure. Yeah, excuse me, I don't sleep much, so I'm just the kind of person I can just stay awake forever. Literally. I sleep, no joke, I sleep on average like 4 hours a night sometimes. And I've been doing that for over 20 years.
Well, at this point, I've been up for about 23 hours.
Oh, good. You're getting there too.
Yeah, and I spent 6 hours on the road, and then whenever I was in St. Louis, I was running around. I went to this place called Warehouse of Stuff.
Warehouse of Stuff?
Yeah, they had surplus computers. I wound up getting 3 iMac G3s for $10.
Well, that's like one of those, yeah, the surplus stores, I've seen those online. Those are really cool.
Yeah, so of the 3 iMacs that I got, it looks like 2 of them work. One of them is locked down, looked like it came out of a computer lab, and nothing like the control panel is inaccessible, so I'm going to have to reformat that one and re-image it. It worked. It had a 6 gig hard drive, had 100 meg RAM. Looked like it was in pretty good condition, and then the other one only had 64 meg RAM. The hard drive was bad on it. Question mark. This didn't boot. And the other one booted, but the screen is kind of blurry. So I'm going to pull the hard drive out of that one.
Oh, that sounds interesting.
Yeah. But, you know, $30, I should have 2 working iMacs.
Oh, yeah.
The other thing I got was this, it's called a video visualizer. It's basically a camera that is mounted above a surface, and there's 2 LED lights, or they're fluorescent lights. So that it gives you a, it's kind of like an overhead projector, but with a video camera instead of optical lens.
That sounds pretty cool.
Yeah, well, I think it would be good for someone like you who does YouTube, and like if you want to show what is on your scratch paper, or if you have a book open, gives you a nice flat area that has a fixed focus, right? So you're not having to mess with the focus. Put it on the surface.
Yeah, I'll definitely have to look into something like that.
That was $20.
20 bucks?
Yeah, I looked it up on Amazon. It sells for like $300.
Wow.
I don't know if it works yet. I haven't hooked it up, but we'll see.
What's it called again?
A video visualizer. It was a Canon. Here, I might still have it on Amazon. Well, actually, this is a YouTube. I put a link in there. I'll look it up tomorrow and see if it works. Not to clean it up; it's filthy. It's the iMacs. They probably had 30 iMacs on on pallets, and they had plywood between them, stacked in tiers. So I had to dig through a pallet load to find ones that weren't all cracked up and scratched and beat up.
Nice.
So yeah, of the 30 that were there, I picked 3 that I thought were the nicest, and turns out 2 of them were working.
That's a pretty cool place, it sounds like.
Yeah, Warehouse of Stuff. They have a website, warehouseofstuff.com.
Of
course, they're in. Where are you at? You're not anywhere near St. Louis.
No, I'm in Arizona. Yeah, change the colors. I'm just playing with it. So later what we'll have to do is set up a color table for this too.
Yeah.
We figure out which color is what. All I did there is I just stuck the top brick inside of there and incremented to the Y to create those funny colors on the screen. Do something like this too. Multiplying by 2. Probably get different colors that way. Or turn black now. Turned off every other one. Oh, this is why it didn't work. I already had the 7 loaded in earlier. I was like, wondering why it didn't work. Top brick. This should change it. Probably multicolor or something. Look what it did.
Yeah, that's weird.
That is really strange. I turned off the bottom ones here. This map I was doing down here. The one is multicolor and one is not. That's what's going on.
What's the temperature in Arizona?
I have a thermometer actually in my room right now. Because it's 80 degrees in here. Doesn't feel like it. Well, I got my fan in my window, so it doesn't feel like it, but it probably is if I turned off the fan. So if you wanted to change and you don't want all those on the screen, just change that CPY 240. Like, how many did you originally have? You only had like what, 4 rows on it?
Yeah.
So you just calculate for 4 rows. I think it was the 160, wasn't it? No, we got. Let's see. I was just doing that to play with it earlier. Oh, I still got too many on there. Oh, that's right, because I never jumped out of the loop. And then that X register, above the X register 6, you want to drop that down. Otherwise, it's going to keep repeating down the next highest bit. We set that to like a 1. And that'll fix it. You just get the top rows there. Now to get the next ones, you just add in the next ones. Rate 2 might do it. I'm just going to skip the space. It's 86, 160. Eventually, what I want to do is just have this all in one line so we don't have to do the first one, the second one. We just do everything in one place. And I'll just draw it off all the way straight down the screen. I think it's good enough for now. I'll put this back to 1. That's 160 plus 8. There's 3 rows. That's as far as we can get before we do the high byte. We got it all working though, huh?
I'm sorry, what was that?
Did you get it working?
I got the last one I got is where you colored it yellow and put it all in.
Okay. I mean, I can give you this one if you want this one too.
Yeah, give me that one too.
I just changed color. The main thing is you'll be playing with those X and Y. Basically, the X register is when you want to add another row, and that Y is going to determine how many you're drawing on the screen each time. Yeah, I'm getting tired. I gotta get up at 9 o'clock in the morning, so I know I gotta be heading out. I gotta be up like 8:30. Okay. As long as I get my 6, I know I'm good.
Check out that video visualizer link there.
What's that?
Check out that link I put in there.
You got what?
That link I put in chat.
The link you put in chat.
Yeah. The video visualizer.
Oh, you didn't get the right one?
Click over into chat. I put a link. Click on that.
Oh, above mine. I see what you're saying there. Okay. Oh, you're showing me what it looks like. Oh, okay. Well, that's pretty cool.
Yeah, this is the thing that I got for $20.
Not bad at all.
Let's see if it works. But you see that, so that's a camera that's mounted above that flat surface.
Yeah, I see that. Zoom in on it.
And then those 2 things on the side are the lights.
Interesting. Cool stuff.
And it's a composite video out.
I can see it right there. It folds up too?
Uh-huh.
That's pretty cool.
Yeah, I think they use these sort of a transition between overhead projectors and just doing PowerPoint, on the computer video projector.
Nice.
I mean, I'll probably send you an email with questions later. If I don't see you sooner, I'll see you next Saturday.
Yeah, for sure. This was a lot of fun. It's definitely late.
Yeah, it was very helpful. Thank you very much.
Oh, you're welcome. Glad you enjoyed it. Everybody else who's been watching. I'm out of here. I'm tired.
Yeah, me too. Later, man.
Yep. See ya. Yep. Bye. And this is Steve Morrow signing off with 0 viewers. Hope you enjoyed the YouTube. Have a good night.